Hi everyone, welcome to this video tutorial on Python data analysis project for 2022. In this video, we'll be covering two interesting hands-on projects using Python programming. You will learn how to use real-world data to perform data analysis and data visualization. The two projects are based on coronavirus and Olympics data. You will learn to collect, analyze, clean, manipulate and visualize data with the help of Python libraries such as NumPy, Pandas, Matplotlib and Seaborn. These two projects will give you the idea to solve real-world problems using exploratory data analysis. So let's get started with our first project. Today, we are going to perform two hands-on projects on COVID data analysis using Python and Tableau. This is going to be a really interesting and fun session where I'll be asking you a few generic quiz questions related to coronavirus. Please make sure to answer them in the comment section of the video. We'll be happy to hear from you. COVID or coronavirus is an ongoing global pandemic of coronavirus disease that emerged in 2019 and was first identified in Wuhan, China. It is defined as an illness caused by a novel coronavirus called Severe Acute Respiratory Syndrome Coronavirus 2, commonly known as SARS-CoV-2. On March 11, 2020, the WHO declared COVID-19 a global health emergency. The virus has so far infected over 22 crore people and killed more than 4.5 million innocents. In India, there have been over 3.3 crore confirmed cases and nearly 4,41,000 deaths have been reported so far. This data is according to official figures released by the Union Ministry of Health and Family Welfare. As the world tries to cope up with this deadly virus, we request all our viewers and their family members to follow all the necessary precautions to avoid getting infected. Quiz time. Now let's see our first quiz in this project. What does corona in coronavirus mean? Here are the options. Is it A. beer, B. respiratory, is it C. crown, or is it D. sun? This is a very generic question. I'm sure a lot of you may already know, some of you may not. Please let us know your answers in the comment section of the video. We'll be glad to hear from you. Now in this video, we will use three different COVID-19 datasets and perform data analysis using Python and Tableau. The project will give you hands-on experience working on real-world datasets and how you can use the different Python libraries to analyze and visualize data and draw conclusions. You will learn how to create different plots in Tableau and then make a dashboard from the visuals. The project will give you an idea about the impact of coronavirus globally in terms of confirmed cases, deaths reported, the number of recoveries, as well as active cases. We will also see how India has been affected since the pandemic started and dive into the different states and union territories to learn more about the COVID-19 influence and the vaccination status. First, let me show you the two datasets that we'll be using. So for our first project using Python, we'll be using the first two datasets, COVID-19 India and COVID vaccine state-wise. Let me open the two datasets. Okay, so this is the first dataset. You can see here we have the date, we have the time, then we have the different state names. If I scroll down, you can see we have Kerala, Tamil Nadu, Delhi, Haryana, Rajasthan, this Ladakh, Punjab, Telangana and other states. Then we have something called as confirmed Indian national. So actually this two datasets, confirmed Indian national and confirmed foreign national, we won't be using. So in the demo itself, we'll be dropping these two columns. What we are concerned about are the last three columns, the cured cases or the recoveries, the number of deaths reported, and then we have the total number of confirmed cases. Let me just sort the B column, that is the date column, so that you have an idea about the recent data we have. I'll continue with the current selection and sort it. You can see here, this is till 11th of August 2021. So this data was collected from Kaggle. It has some discrepancies that we will see in the demo. The data is available for free. We will provide the link to the datasets in the description of the video, so please go ahead and download them. The visualizations and results that you will see in the demo are based on the datasets that we'll be using. We haven't pre-processed the data to remove outliers or any missing values. Now before I jump into the demo, let me show you the second dataset that we are going to use. Okay, so COVID vaccine state wise is my second data set. Let me open it. There you go. So this is the second data set that we'll be using in the Python project. You can see we have a column called updated on, then we have the state. Again, you can see here there are a few discrepancies here. It has taken the country name and not the state name. Below you can see there are the different state names, and you can also see we have information about the total doses administered. We have the sessions, sites, first dose administered, then we have the second dose, then we have information about male and female doses. You can see here the different vaccines administered, Covaxin and Covishield. You have Sputnik V, and here are the different age groups as well. And finally, if you see, we have male individuals vaccinated, the total number of female individuals vaccinated for a particular day. We have information about transgender individuals vaccinated, and finally we have the total individuals vaccinated each day. Alright, before we jump into the hands-on part, let's have a look at the second quiz in this project. So here is the second quiz question. Which is the first country to start COVID vaccination for toddlers? Is it A, Japan, B, Israel, C, Portugal, or is it D, Cuba? This is a very recent development that took place. If you watch daily news updates on coronavirus, you will be definitely able to answer the question. Please give it a try and put your answers in the comment section of the video. It is really important for our viewers to know the right answer. Alright, so now let's begin with our demo. So I am on my Jupyter notebook. So the first project we are going to use Python Jupyter notebook. I'll just rename this notebook as COVID Data Analysis Project. I click on rename. Alright, so first and foremost we need to import all the necessary libraries that we are going to use. So first I'm importing Pandas as PD. This is for data manipulation. Then we have NumPy as NP. NumPy is used for numerical computation. Then we are importing Matplotlib, Seaborn and Plotly. These three libraries will be used for plotting our data and creating interesting visualizations. Finally, I'm also importing my datetime function. Alright, so I'll hit Shift Enter to run the first cell. Now it's time to load our first data set, which is related to the COVID-19 cases in India for the different states and union territories. So I'll create a variable called COVID_df. df is for data frame. I'll use my Pandas library and then give the read_csv function, since our datasets are CSV files, and inside double quotes I'll pass in the location where my datasets are present. So I'll just copy this location, I'll paste it here. We'll change the backslash to /, and after that I'm going to give my file name followed by the extension of the file. I'll say COVID-19 India.csv. Let's go ahead and run it. Alright, now to see the first few rows of the data frame, I'm going to use the head function. I'll say head, and within brackets, let's say I'll pass in 10, which means I want to see the first 10 rows of data. If I run it, there you go. Here you can see from 0 till 9. So we have 10 rows of information, and these are the different column names. You have S number, date, time, state or union territory. Then you have confirmed Indian national, confirmed foreign national, cured cases, deaths reported, and the confirmed cases. Alright, now moving ahead, let's use the info function to get some idea about a data set. If I run it, you can see here it gives us the total number of columns, we have 9 columns. The total number of entries or the rows, we have 18,110 rows of information starting from 0 till 18,109. You see here the different types of variables or column names that we have. Then it has information about the memory usage as well. And this side you can see the data types. Cool. Now we'll use another very important function, which is to get some idea about statistical analysis, the basic statistics about your data set. For that I'll be using the describe function. Okay, so if you can see here, the describe function is for numerical columns only, and you have the measures such as count, the mean, standard deviation, maximum, minimum, the 25th percentile, 50th percentile, and the 75th percentile value. Okay, now let's move ahead and import the second data set, which is related to vaccination. So I'll create a variable called vaccine_df. I'll write pd.read_csv function, which is present in Pandas library. I'll move to the top and I'll copy the file location and we'll change the name of the file. Copy this and let me paste it here, and instead of COVID_19_India, I'm going to say COVID_vaccine_statewise. Okay, so this is the dataset that we saw, COVID_vaccine_statewise. Alright, let me run it. Cool. And let's display the first 7 rows of information from this data frame. I'll be using the head function, and inside the function I'll pass in 7. There you go. So here you can see we have from 0 till 6. There are total 24 columns. A lot of them have null values, you can see here. Alright. Now from the first data set, which is the COVID_df data frame, we'll be dropping a few unnecessary columns such as the time column, confirmed, Indian national and confirmed, foreign national, as well as the S number. We don't need these columns, so it's better to learn how to drop the columns for our analysis. So I'll say COVID_df dot, I'll use the drop function, and within square brackets I'll pass in the column names. The first is S number. I'll give a comma. Within double quotes I'll say the next column is time. My third column that I want to drop is confirmed Indian national. Give another comma. Within double quotes I'll say confirmed foreign national. Outside the square brackets I'll give another comma and pass in my next argument, that is in place equal to, I'll say true. I'll give another comma and say axis equal to 1. Let's run it. Okay, it has thrown an error. Let's debug the error. Says confirmed Indian. Okay, it should be Indian national and not Indian nation. I'll just mention it as national. We'll run it again. Okay, now we have removed these 4 columns. Let me show you the dataset now. There you go. So we have only the date column, state or union territory, cured, deaths, and confirmed. Now let's see how you can change the format of the date column. For that you have the function called toDateTime. I'll say COVID_df. I'll pass in my column name, that is date. I'll say equal to pd dot. I'll use the pandas function, that is to_date time. I'll say COVID_df, which is my data frame name. Pass in my variable, which is date. Give a comma, and I'll use my argument, that is format equal to. I'll say %y. Give a dash, say %m. Give another dash and say %d. Let's run it, and I'll print the head of the data frame. Cool. Now moving ahead, now we will see how to find the total number of active cases. So active cases nothing but the total number of confirmed cases minus the sum of cured cases plus deaths reported. So let's find the active cases. I'll give a comment. Okay. I'll first write my data frame name, that is COVID_df. Within square brackets, I'll give my new column, which is active_cases. I'll say equal to COVID_df, and my first column would be the confirmed cases column minus, I'll say COVID_df. Then I'll pass in my cured column plus, I'll again say COVID_df and add my deaths column. This time let's print the last 5 rows from the new data frame that we have created. Okay, let's run it. Okay, it has thrown an error. Let's debug it. Says data frame object has no attribute tails. This should be tail. There you go. You can see here we have added a new column called active cases, which is the confirmed cases minus the sum of cured and deaths reported column. Now we will learn how to create a pivot table using the Pandas library. So in this table we'll be summing all the confirmed deaths and cured cases for each of the states and union territories. So we'll be using the pivot_table function for this. I'll create a variable called statewise and say pd dot. I'll use the pivot_table function. I'll pass in my data frame, that is COVID_df, and then I'll give my values parameter. Inside the square brackets I'll pass in my columns confirmed deaths, and then we'll have the cured column. I'll give a comma, and next argument would be index, which is going to be my state slash the union territory column. Let me bring this to the next line so it is more readable. I'll say union territory. I will give a comma now and pass in my last argument, which is agg function, that means aggregate function, and this function would be max. Alright, let's run it. Okay, now I'm going to find out the recovery rate. So recovery rate is basically the total number of cured cases divided by the total number of confirmed cases into 100. So I'll say state-wise, and within square brackets I'll pass in my variable that I want to create, which is recovery rate. This will be equal to the cured cases multiplied by 100 by the total number of confirmed cases. Within square brackets I'll give my column as confirmed. Let's run this. Okay, I'll just copy this column, paste it here. So this time we are going to find out the mortality rate. So mortality rate is nothing but the total number of deaths divided by the total number of confirmed cases into 100. So I'm just going to replace the names. Here I'll say mortality. Alright, and then instead of cured I'll say my deaths column into 100 divided by the confirmed cases. Let's run it. Okay, now we are going to sort the values based on the confirmed cases column, and we'll sort it in descending order. So let me show you how to do it. I'll say state-wise equal to, I'll use the function sort underscore values. So I'll pass in my variable state-wise dot and use the sort underscore values function. I'll say by, I want to sort it by my confirmed cases column. Give a comma and I'll say ascending equal to false. Let's run it. Now we are going to plot our pivot table using a nice visual. So for that I'm going to use my background underscore gradient function, and inside that function we'll pass in our CMap parameter. I'll show you how to do it. I'll say style dot background underscore gradient, and inside this we'll pass in a parameter called CMap. So CMap stands for color maps. This is present inside the Matplotlib library. So here you can see there's a nice documentation on choosing color maps in Matplotlib. This is provided by matplotlib.org. If I scroll down, you can see there are a number of CMaps that you can use. Purples, blues, you have something called reds. There are other things like magma, you have summer, autumn, spring, winter, cool, all these. You can use whichever color map that you want, and here you can see the different shades or the gradients. Okay, so I am going to use my color map as cube helix. Let me run it and show you the pivot table. There you go. Here you can see we have our pivot table ready. Now, as I said in the beginning, there are a few discrepancies in the data set. So here you can see there's one called Maharashtra, and there's also Maharashtra triple star. This you can ignore. Even if I scroll down, you have Madhya Pradesh followed by 3 asterisks. You can ignore this value as well. Even for Bihar we have. So these have been duplicated, and here you can see the different state names and union territories. Then on the top you have the confirmed cases, cured cases, the deaths reported, and the new columns that we created. These are calculated columns, recovery rate and mortality rate, and we have ordered it in descending order of confirmed cases. So far our data says that Maharashtra has the highest number of cases, followed by Kerala, Karnataka, Tamil Nadu, Andhra Pradesh and Uttar Pradesh. So these are the top 5 states which have the highest number of confirmed cases. Even if you see, the mortality rate is also high for Maharashtra, and if I scroll down, the mortality rate is also high for Uttarakhand. If you see here, if I scroll further, you have Punjab, the mortality rate is also high. Alright, so this was our first visual that we created in the COVID data analysis project. Now moving ahead, we'll see the top 10 states based on the number of active cases. So we'll start. I'll give a comment, top 10 active cases states. Okay. So we are going to explore another very important Pandas function in this, which is known as group by. So I'll first pass in my data frame, which is COVID_df dot followed by the group by function. I'm going to group my data based on state/union territory column. Then I'll say dot max, which is to find the maximum value from the states that have the highest active cases. So I have passed in my active cases column, and we're also going to group it based on the date column. After that, we are going to sort the values. So I'll use my function that is sort_values. I'll say sort by my column that is active cases. Let me bring this to the next line. Underscore cases. I'll give a comma and say ascending equal to false. Say dot, and then reset my index. For that I'll use reset_index function. Okay, let's check if everything is fine. I have missed a square bracket here. Let me give another square bracket here. Okay, and all this we are going to store in our variable called top_10_active_cases. Okay, now let me go ahead and run this cell. Okay, there is a syntax error here. Now let's run it. Okay, now I'll create another variable called fig. Here we'll pass in the plt, which is for Matplotlib library, and we'll give the figure size using the fig size argument. It's equal to, and within a tuple and passing the size, let's say 16,9. We'll run it. Okay, and let's give a title to our plot. So here we are going to create a bar plot. So using plt.title, we'll pass in the title, let's say top 10 states with most active cases in India. I'll give a comma and pass in the size of my title, let's say 25. Okay, you can see we are slowly being able to create our graph. The most important thing is to pass in the x-axis and the y-axis. I'll say ax, which is for axis. To pass in the axis, I'm going to use the bar plot function that is present inside the Seaborn library. I'll say sns.barplot. I'll say data equal to my variable, which is top underscore 10 underscore states. This is actually active states. Alright, and now I'm going to use the iloc function and take the first 10 states. So I'm using a colon and then giving 10 as my value. ILOC is for index location. I'll give a comma and say my y-axis to be active cases. Give another comma and say my x-axis to be state / union territory. Give another comma. We are going to pass in the line width to 2. I'll say line width equal to 2 and we'll give an edge color. Let's say the edge color is red. Okay, so I have my axis defined now. Let's run it. There's an error here. It says top 10 active states not found. Let's go to the stop and see the exact. Okay, so this is top 10 active cases. Let me change it to cases here. Now run it. Okay, the x-axis also has a mistake. This should be state / union territory. Now let me run it. There you go. We have our plot created, but as you can see here, the labels of the different states and union territories are overlapping. So for that, let me first pass in the x labels. I'll say plt.x label, and my x label would be states. Then I'll say plt.y label. My y label will have the total active cases. And finally, I'll write plt.show. Before I run it, let's collate all the lines of code that we have written for our top 10 states for most active cases in India into one cell. So what I'll do is I'll just copy this and we'll keep adding in this cell itself. Okay, I'll go to the top. Next, we'll copy my figure size and we'll paste it here. Next, let's take the title and put it here. Give a space and we are going to copy this cell and I'll paste it here. Alright, now it's time to run it. There you go. You see it here. We have a nice bar plot ready. On the top you can see the title, top 10 states with most active cases, and you see the edges are in red color for all the bars. On the x-axis you have the different state names: Maharashtra, Karnataka, Kerala. You also have Andhra Pradesh, Gujarat, West Bengal and Chhattisgarh. So as you can see, Maharashtra has the highest number of active cases based on our data, followed by Karnataka, Kerala and Tamil Nadu at 2nd, 3rd and 4th place respectively, and in the 9th place we have West Bengal, in the 10th place we have Chhattisgarh. On the y-axis you can see the total active cases, which are in lakhs. Okay, now moving ahead, now we'll see the top 10 states based on the total number of deaths reported. So I'll give a comment, top states with highest deaths. Okay, so I'll first create my variable saying top 10 underscore deaths. This will be very similar to what we did here, just that we need to change a few column names. So instead of active cases, we'll be using deaths. Okay, so I'll start with my data frame, that is COVID underscore df, followed by using the group by function, and I want to group my data based on the state slash union territory column. Then I'll choose the max function, and within double square brackets I'll pass in my column names deaths and date. Let's make it consistent. I'll be using single quotes. Okay, I'll say dot, gonna sort my result, therefore I'm using the sort underscore values function. I want to sort it by deaths column. I'll give another comma and say ascending equal to false, which means I want to order my result in descending order. Then I'll say dot reset underscore index. Okay, after that I'll give my figure size. I'll say plt dot figure, and within brackets I'll pass in my argument, which is fig size equal to, using a tuple I'll say 18 comma let's say 5. Now let's give a title. For that I'll use the title function which is present in the Matplotlib library. I'll say top 10 states with most deaths, and let's give a size to the title 25. Now it's time for us to give the access labels. I'll just scroll down. Okay, so I'll say ax equal to, again this will be a bar plot, so I'm using my cbourne library followed by the bar plot function. My data will be top underscore 10 underscore deaths, which is this variable. I'll give my index location ILOC. I'm going to choose 12 states. The reason being, there are some discrepancies in the data. I'll show you once I plot this result. So in the y-axis we'll have deaths column. In the x-axis we'll take state slash union territory. Okay, I'll give another comma and say line width equal to 2, and we'll give an edge color to our bars like we did here. So I'll say edge color equal to, let's say, black. Okay, now finally we'll give the x label, the y label. So I'll say plt dot x label. X label would be states. My y label will be total death cases. Then I'll write plt dot show. Now let's run it. There you go. You can see here we have a nice bar plot. On the top we have the title top 10 states with most deaths. Now what I specifically wanted you to see was these discrepancies in the data. You can see here Maharashtra is repeated twice. Even in our data that we collected from Kaggle. Karnataka spelling has an error. You can see here we have a few rows of information where Karnataka is spelled as K-A-R-A-N instead of K-A-R-N-A. Alright, so to remove these two results or to ignore these two results, I had given my index location till 12. So we have Maharashtra, Karnataka, Tamil Nadu, Delhi, then Uttar Pradesh, West Bengal, Kerala, Punjab, Andhra Pradesh and Chhattisgarh with the states that have the most number of deaths reported. Okay, now we'll create a line plot to see the growth or the trend of active cases for top 5 states with most number of confirmed cases. So the states are Maharashtra, Karnataka, Kerala, Tamil Nadu and Uttar Pradesh. I can show you. So these are the states with highest number of active cases. Okay, I'll just give a comment saying growth trend. Alright, so for that we'll start with our figure size as plt.figure. I'll use my parameter fig size equal to 12,6. I'll say my axis as SNS dot. This time we are going to create a line plot. My data would be my original data frame, that is COVID_df, and within square brackets I'll say COVID_df, and we are going to pass in the state or the union territory column. I'll give a dot and use the isIn function. So the states should include Maharashtra, I'll give a comma. The next state should be Karnataka. Next we have Kerala. Give another comma. My fourth state is Tamil Nadu. Give a comma, and my fifth state would be Uttar Pradesh. Alright, so I'll give a comma here and then say x equal to the date column, y will be active cases column, and I'm going to use another parameter called hue, which is to give different colors to the different states, the 5 states that we are looking for. So hue will be my state/union territory column. Okay, after this I'll say ax dot set title. My title will be top 5 affected states in India. We'll give a size, let's say 16. Alright, okay, this should be size equal to 16, and to make sure everything is fine, let me just move it to the above line. Okay, now we'll run it. Okay, there is some error again. It says invalid syntax. Let's see where we went wrong. Let me bring this to the above line. Okay, this should be COVID_df. Okay, make sure you keep these small errors in check. Let's try and run it again. Alright, if I scroll down, there you go. Here you can see we have the top 5 affected states in India. you see the different states here and the colors. So this violet or the purple color is for Maharashtra. You can see how the active cases surged around April and May, and then you can see even for Karnataka the active cases surged very rapidly around May and June. Then it has decreased, luckily. Similarly, you can see the plots for even Uttar Pradesh as well as for Tamil Nadu. So all the 5 states, you can see one common trend that after March, so around April, the cases started to emerge very rapidly, and later after July they started dipping. Okay, now we are going to use our second data set, which is related to vaccination. Alright, so first and foremost, let me go ahead and print the data frame for you so that you know the data that we are going to use. So this is the data we are going to use for our next set of analysis. Even this data has a few errors, and you can see there are a lot of missing values. It makes sense because not all the days you would have vaccination for people, and very crucial error that we are going to deal with is this state column. Here you can see in the state column we have India in a few rows, so we are going to ignore these rows. Alright, first let's rename our updated on column to just vaccine date. So you can use the rename function present in the Pandas library to do it. So I'll say vaccine underscore df dot rename. I'll say columns equal to, within curly braces I'll write updated on, which is my original column name, give a colon. I want to change this to vaccine underscore date. I'll give a comma and say in place equal to true. So it will change my column name from updated on to vaccine underscore date in the original data frame. Let's run it. Now let me go ahead and print the first 10 rows in the dataset. You can see here we have successfully changed the column name to vaccine underscore date. The rest of the columns remain the same. Alright, now you can check the total number of columns, rows, the data types, and the memory usage using the info function. Here you can see it. We have total 24 columns, 7,845 entries, and these are the columns that are present. And if I scroll further, you see here says the memory usage, and here on the right you can see the data type. Cool. Now as you saw, the data has a lot of missing values. Let's find the sum of all the missing values for each column. So I'll say vaccine underscore df dot is null, and then I'm going to use the sum function over it. If I run it, there you go. So almost all the columns have missing values, but columns such as male individuals vaccinated, female individuals vaccinated, even for columns like the age groups, there are a lot of missing values. Now in the next step we are going to draw up a few missing value columns. So I'll say a new variable called vaccination, I'll give the data frame name vaccine_df and use the drop function. And inside the drop function, we are going to write columns equal to, I'll pass in the column names that I want to drop. I'll say doses administered. So this is the column that I want to delete, Sputnik V doses administered. I'll give a comma. The second column is AEFI. The next column is 18 to 44 years. Within bracket it has doses administered. Give a comma. I'll say 45 to 60 years, doses administered. Give another comma. The final column that we are going to drop is 60 plus, which is this one, 60 plus years. Doses administered. Okay. So these are the columns that we want to drop. And finally, I'll give my parameter access equal to 1. Okay, let me just recheck these column names. First one is Sputnik V doses administered, then we have AEFI followed by 18 to 44 years doses administered, then we have 45 to 60 years doses administered. Finally, we have 60 plus years. I have added a S here which was missing, and there should be a space as well because there's a space here in the column. Now let's run it. Alright, so we have successfully dropped the columns that we wanted to drop. Now I'll say vaccination.head. You can see here we have dropped those columns and we are left with these columns now. Okay, now we are going to create a plot, that is a pie plot, to see the vaccination for male and female individuals. So I'll give a comment as male versus female vaccination. To create this pie plot, I'm going to use the Plotly library that we had imported, which is this one, Plotly. Okay, so first of all we need to filter out the male individuals from our data frame. I'll say male equal to vaccination male. I'll passing in the column individuals vaccinated. Need to recheck the variable name whether it is correct or not. You see here male individuals vaccinated. Then I'll say dot sum. Similarly, we'll filter out the female individuals. I'll say female equal to vaccination, which is my new data frame. Within square brackets, I'll pass in the column name female individual vaccinated. I'll say dot sum. Okay, these should be individuals as per the column name present in the data frame. Cool. Now I'm going to say px dot py function, which is present in the Plotly library. I am going to give the names of the pies. So first one is male and the second one is female. Give a comma and say values equal to male comma female. Then I'll give a comma and pass in my title, which is male and female vaccination. Okay, this should be names. Alright, now let's go ahead and run this cell. So it will take some time to create the pie chart. Here we go. See, here I have my title, male and female vaccination. So these are the two pies or the areas. You have the label female and the value. Here you have the label male and the value. So from our data you can see 53% male individuals have been vaccinated compared to 47% for females. Okay, now we are going to drop all those rows where our state was mentioned as India in the original dataset. I had shown this to you in the beginning, so we are going to remove rows where state is India. Okay, so to do that I'll say vaccine. I'm creating another variable called vaccine and we'll use our original data frame that we had imported, which is vaccine underscore df. I'll say vaccine underscore df dot state not equal to India. Now let's print vaccine. Okay, you can see here we have our data frame printed, and from this data frame we are taking only those values or the rows where state is not equal to India. Cool. Now what we are going to do is we'll rename the last column, which is total individuals vaccinated, to just total. So I'll say vaccine dot rename. We'll use the parameter columns equal to, within curly braces I'll say total individuals vaccinated, give a colon, and we'll change this to just total, give a comma and say in place equal to true. And finally I'll print my head of the new data frame. This should be columns equal to. Okay, now you can see here, if I scroll to the right and if I check, we have successfully renamed our column. Alright, now moving on to the last two visualizations that we'll see in this first project using Python, that is to find the states with most number of vaccinated individuals and the state with the least number of vaccinated individuals. Okay, just give a comment, most vaccinated state. Okay, for this I'll first create a variable called vax underscore VAC, which is for maximum vaccination. I'm going to use my data frame vaccine followed by the group by function. I want to group it by state column and we'll find the total sum of vaccinated individuals For each state, I'll convert this to frame. There should be a dot, 2_frame, and I'll pass in my column name, which is total. After that, I'll say max_vac equal to max_vac dot sort underscore values. I'm going to sort it by my total column and say ascending equal to false, which means I want to sort it in descending order so that we have the states with the highest number of individuals vaccinated. I want the top 5 states. Now let's go ahead and print it. So this will create a nice table for us. There you go. Here you can see we have Maharashtra, Uttar Pradesh, Rajasthan, Gujarat and West Bengal as the top 5 states with most number of vaccinated individuals. Now we are going to use this table and convert it into a chart. Now I had already written my code for the bar plot. I'm just going to paste it. So here I have defined my figure size as 10,5. Then I'm giving a title as top 5 vaccinated states in India and the size is 20. After that, I've created a variable called x, which is going to store my bar plot. This bar plot we have created using the Seaborn library, and you see here I have my y-axis defined. Then I have the line width and the edge color as well. I have given my x label as states, y label as vaccination, and I'm finally going to display my plot. So let's go ahead and run it. Okay, you can see it here. We have converted this table into a bar plot now. So first we have Maharashtra with the highest number of vaccination. Then we have Uttar Pradesh, Rajasthan, Gujarat and West Bengal. Now I want the viewers watching this video to find the states with least number of vaccinated individuals and convert that table into a bar plot that will show the bottom 5 vaccinated states in India, which means the states which have least number of individuals vaccinated. So please go ahead and put your codes in the comment section of the video. It will be very similar to these two cells, just that now we want to know the least 5 vaccinated states in India. So please put the code snippets in the comment section of this video. We'll be more than happy to know from you. In case you are not able to do it, we'll definitely give the answers in the comments itself. Alright, so this brings us to the end of the first project on COVID data analysis using Python. So in this project we used 2 datasets. One was on the COVID-19 India dataset for different states and union territories, and the second dataset that we used was for analyzing the status of vaccination in the different states in India. Now we'll move on to our second project. Okay, so before moving on to our Tableau project, let's see the final quiz. Which of the following is not a common coronavirus symptom? So this question is to make you aware of the correct COVID symptoms. Here are the options. Is it A, fever, B, vision loss, C, loss of taste and smell, or is it D, cough? Please put your answers in the comment section of the video and let us know what you think. Now we'll move on to our second COVID data analysis project. For this project we'll be using the Tableau software and a global coronavirus dataset. First we'll look at the dataset and the fields we have. Okay, so I am in my dataset folder. We have already seen the first 2 datasets in our Python project. This time we are going to use the global COVID data. Let me open it. Alright, so here you can see we have the different country names. There are 192 countries in our dataset. Let me go to the top. So we have country or region. We also have the code for each of the countries. Then we have a column called last updated. So here you can see our data is still 12th of March 2021, and there are two columns which don't have any information, that is people hospitalized and people tested. Then we have a column called active cases. Then we have a column for confirmed cases in the different countries. We have the number of deaths, and then we have the incident rate, the latitude and the longitude for the countries. Then we have the mortality rate, this is in fractions. Then we have the number of recovered cases, and finally we have a column called UID. So we'll be mostly using the country column, active, confirmed, deaths, and the recovered cases column. And we'll be using the Tableau software to create interesting visualizations, and we'll convert those visuals and put it in the form of a dashboard towards the end of the project. Okay, so let me close this file, or let it be open. I'll search for Tableau public. You can see here I have Tableau public installed. You can use the desktop version of Tableau or the public version of Tableau. So for this project we are going to use the Tableau public edition. So here you can see I have created a few visuals already. If you want, you can clear them out. Okay. Now the first thing we need to do is to connect our CSV dataset to Tableau. For that, under connect we have to a file. I'm going to use text file, and under Chrome downloads I'll search for my folder COVID-India, and here I have my global COVID data file. Let me open it. This will take some time to load. There you can see. So on the Tableau you can see the view here. It shows the country or the region. You have the last update. You have columns like active, confirmed, deaths, mortality rate, and recovered. And here you can see the symbols for the different columns. So this is a globe, which means this field is a region or a geographic field. ABC means it's a text field. Then we have the calendar, which is for a date field. ABC are text field, and this hash represents numeric fields. Alright, so now that we have loaded our data, let me just click on sheet 1. So this is the canvas where we are going to create our different reports. Alright, so on the left you can see there are two panes, the data pane and the analytics pane. In the data pane you can see the name of the dataset, global COVID data, and here you can see the different columns that we have in the dataset. So on the top, the ones marked in blue are called as dimensions, and at the bottom whatever you see are marked in green and are called as measures. So dimensions are always represented with blue icons and measures are in green icons. So Tableau has automatically detected the different data types for each of the columns. Alright, so first of all we are going to create a simple table to see the total number of confirmed cases for each of the countries. So for that I'm going to drag my country or the region column onto rows. Here you have rows. I'll just drag it and drop it here. There you go. It has populated all my country names starting from Afghanistan till Zimbabwe. So it has ordered in ascending order of alphabets. Now to see the total confirmed cases for each country, I'm going to drag my confirmed column onto text. So here under marks card you have the text option. I'll just drag it and drop it here. There you go. So Tableau how easily has shown me a table where you can see the different country names, and on the right you have the total number of cases that have emerged from these countries. Now this is not the most recent data, as I told you this data was till March 2021. Cool. Now you can go ahead and sort the table based on the total confirmed cases. Here on the top you can see here there are two options to sort in ascending order or in descending order. Let's first sort in ascending order by sum of confirmed cases within country and region. There you go. So here you can see these are the countries which have very few cases, and if I scroll down you have France, UK, Russia, Brazil, India and US with the highest number of COVID-19 cases. If you want, you can also sort it in descending order so that the countries with the highest number of confirmed cases appear at the top. You can see it here, and these are the countries that have very few COVID cases. Now you can convert this simple table into different charts and graphs. To do that, here on the right top corner you have an option called show me. Now I can just click on this horizontal bar graph, so that will automatically convert my table into a bar graph. Again you can go ahead and sort the data. There you go. So here you have US, India, Brazil, Russia, UK, France, Spain and Italy. This is a horizontal bar graph sorted in descending order of confirmed cases. Now suppose you want to display only the top few countries with the highest number of confirmed cases. For that you can select these bars. So I'll select till, let's say, Germany, or let's say till Argentina. Okay, and I'll click on keep only. You can see it here, it says 12 items selected, that is the sum of confirmed cases. I'll just click on keep only. There you go. So this horizontal bar graph has information only for these few countries that have the highest number of confirmed cases. Now you can go ahead and play with the color formatting. So here under colors, let me choose a green color. Okay, now you can mark here, since we selected only the top 12 countries with the highest number of confirmed cases, so what we did was we just filtered it to the top 12 countries. So Tableau has automatically added country region in the filters card. Now if you want, you can go ahead and edit this filter as well. Suppose you want to remove Argentina, you can just uncheck this, click on apply and OK. You see here Argentina has been removed. I'll click on undo, so Ctrl Z to get it back. Cool. Now you can convert this horizontal bar plot into a vertical bar plot. Let me show you how to do it. I'll just remove these fields from my chart. Now what I'm going to do is I'll drag country or region onto columns, and I'll have a confirmed column under rows. There you go. Here you can see we have a vertical bar plot now, and again you can use the axis now to sort your data. This is in descending order. Similarly you can sort it in ascending order. Here you have the option to sort your data. Okay, cool. And below you can see the different country names. Alright, now you can go ahead and give a name to this sheet. Let's say top 10 confirmed countries. Just apply and click on OK. You have the title to this plot. Similarly you can change it here as well. Top 10 confirmed countries. Okay, now let's move on to our second visualization, where we will create a global map. So this global map will show the different countries present in the map and the cases that they have. So to create the map, first I'll drag my longitude generated field onto columns, and then I'll drag latitude onto rows. You see here we have the map ready, and now I'll drag country region onto detail. So this will give you the different country names. You can see here we have Canada, the United States, Mexico, here you have India, Sri Lanka, there's Australia, this is Brazil, and similarly we have Spain, France, Belgium, there's Italy here, we have also Greece. Similarly we have the African countries like Central African Republic, there's Congo, Angola, and on the top you have Russia, and this is Iceland, so on and so forth. Now I'm going to drag the active cases column onto detail again. Now if I hover the cursor, you can see the active numbers for Brazil, you can see for India, you have countries like China, then here you have Thailand, Algeria. Now I'm going to drag the confirmed cases column onto label, so that you have the labels here. You can see here the confirmed labels. Cool. Now if you only want to focus on a few countries present in a particular region, you can highlight that region. For example, suppose for Europe you want to focus on this region. If you select it, it will highlight only those countries, and if you hover your mouse over these points, it will show you the active cases and the total number of confirmed cases. Alright, now if you want, you can go ahead and change the color of the circles. Let's say I'll keep it as red. Okay, so this is how you can create a map to represent the different active and confirmed cases. I'll rename the title to global cases. I'll just click on apply and OK. Similarly, I'll change the sheet name as well to global cases. Okay, now from this map you can see the countries such as USA, Brazil, you have Russia and India with the highest number of COVID-19 cases. Even in countries such as Spain, the numbers are really high, and a lot of the African countries were also impacted. And these small countries like Solomon Islands, you have Fiji Islands with few number of cases, even for New Zealand as well. Alright, now moving to our next visual. Now we are going to see the top 10 countries where highest deaths have been reported so far due to the pandemic. For this we will create a tree map now. So first of all, I'll choose my country column and put it under columns, and then I'll select the deaths column and put it under rows. I have the bar plot ready. Next I'll go to show me, and here I have the option to select a tree map. You see here, for a tree map you need one or more dimensions and one or two measures. So I'll just click on this tree map. Okay, here you can see I have my tree map ready. So Tableau has automatically adjusted my fields, so it has removed my fields from rows and columns and put it under size, color and label. Next I will drag my country column and put it under filters, and from here I'm going to choose top. I'll filter by field. I'm going to select the top 10 countries based on the total number of deaths. Just click on apply and click on OK. So these are the countries: US, Brazil, Mexico, India, United Kingdom, Italy, Russia, Spain, France, Germany, which have the highest number of deaths reported. Now you can also give the label. I'll put the deaths column under label so that you have the labels here. Alright, so this was a tree map that we created to show the top 10 countries with the highest number of deaths. I'll just change the title: top 10 deaths cases. Now you can also edit the title in terms of the font, color and everything. I'll keep it Tableau bold and I'll choose this as 14. Click on apply and OK. There you go. Similarly, let's rename the sheet to death cases. Cool. Now moving to the next visualization, where we'll see about the recoveries. So before we move on to create a visualization for the top 10, or let's say the bottom 10 countries in terms of recoveries, let me show you how to change the color of this tree map. So here by default Tableau selects the automatic palette. If you want, you can change it to different palettes. Let's say I'll go with gold, purple, diverging. Click on apply and I'll click on OK. If this is not looking that great, you can select another one. Let's say red, green, white, diverging. Cool. Now let's go to our fourth visualization, which is about top 10 recoveries. I'll click on apply and OK. First, I'll drag my country or the region column under columns, and then I'll take the recovered column under rows. This time, instead of sum, we are going to choose average. Okay. And here I'll select my packed bubble chart. After that, I am going to drag my country or region onto colors, and then I'll also put country under filters. So I'll go to the top menu and I'll filter it by field. I want to show the top 10 countries based on the average number of recoveries. So click on apply and OK. You can see here these are the countries that have the highest number of average recoveries. You have India, Brazil, Turkey, Italy, Argentina, Germany, Colombia, Russia, Poland and Mexico. I'll just rename this sheet to recovery cases. Cool. Now let's move on to our next visual. Okay, so here we are going to create a scatter plot to analyze the total confirmed cases versus the total number of deaths. So whenever you have two numeric fields, it is better to create a scatter plot to visualize the cases. So for that, I am going to drag my confirmed cases to columns, and then I'll drag my deaths column onto rows. Okay. So by default, the shape is a circle, and to see all the countries, I'm going to drag country under color. I'll say add all members. There you go. Here you can see the legend for the different countries, and on the top you have US with the highest number of confirmed cases and the highest number of deaths as per our data set. Then you also have Brazil here which has the second highest number of deaths. Then you have Mexico followed by India. So this data is not a very recent data. This data was last updated on March. Now from this we are going to filter out the top 10 countries with the highest number of confirmed cases and the deaths. So for that I'll drag my country column onto filters and I'll go to top, I'll filter by field, I'll say top 10 and I'll click on apply and OK. So here you can see we have Siberia, Sweden, Belgium, Netherlands, Spain, Italy, France, Russia, UK, and you have Brazil. So these are the countries which have the highest number of active cases. So instead of active, let's select deaths, click on apply and OK. Okay, now if you see we have US here, Brazil, India, then Mexico, UK, Russia, France, Italy, Germany and Spain, which have the highest number of deaths reported so far. Now if you want, you can change the size of the circles based on the highest number of active cases. So I can just drag my active column under size. So you can see here Spain, France, UK have the highest number of active cases. Now let's say instead of active I'll just have my confirmed cases under size. Okay, and then you can also change the shape from circle to any other shape, let's say square or this asterisk. Okay, let's go with the triangle. Cool. I'll rename this sheet to confirmed versus deaths. Click on apply and OK. I'll rename this to confirmed versus deaths. Alright. Now moving on to our next visualization, where we will see the mortality for each of the countries and figure out which countries have the highest mortality rate. Okay. So first I'll drag mortality rate onto column and then I'll have my country column under rows. So there you go. Now let me go ahead and sort it in descending order. So you can see here you have Yemen, there is Mexico, Syria, Sudan, Egypt, Ecuador, China and other countries which have the highest mortality rate. And you can also select the country region under colors. Let's go ahead and edit the color. Instead of automatic, let's select summer, or you can go for some other palette. Let's say Tableau Classic Medium. I'll assign this palette. Yes, I'll apply and OK. Alright. Finally, we'll move ahead to our last visualization where we'll create a dual axis chart. So the dual axis chart in Tableau will have one column and two different visualizations on the rows. So here you have one column and on the right also you'll have one column with their own axis values. So this dual axis chart will be for recovered cases and the death cases. Let me show you how to do it. So I'll drag my country field onto columns and then I'll choose recovered column onto rows. So here I have got my line chart, and the second column I'm going to choose is the deaths column, I'll hold my cursor and I'll place it when I get this green color rectangle. I'll place it here. There you go. So now we have created two measure names, deaths and recovered, and here you have the access values. You can synchronize the access values if you want. The recovered cases are in millions and the deaths are in thousands. Now let's go ahead and change the recovered line to bars, and we're going to sort it. Okay, now let's change the color. We'll select, let's say, blue. I'll assign the palette, click on apply and OK. And if you want, you can also change the color for deaths from blue to, let's say, winter. I'll assign the palette, click on apply and OK. You can have whichever color you want, and to make the axis same, you can just right click on this axis and click on synchronize axis. So here you can see the values. Let's keep it in thousands only. Cool. I'll rename this sheet to dual axis. Okay. Now before we move ahead and create our final dashboard, I want to show you one more feature in Tableau, that is to format the labels. So you can see here, instead of writing 5,30,821, we can change this in terms of millions or thousands and write it as, let's say, 530k. To do that, what I'll do is I'll go to format, and here we have the option to select font, and in font I'll go to fields and click on sum of deaths, and here in this pane I'll choose number custom, decimal places will be 0, and display units I'll select thousands. You can see here the values have been changed to 531k, 193k, 158k, so on and so forth. Cool. Now let's go ahead and create our final dashboard. Here is the option to create a new dashboard. So I'll just click on new dashboard, and we are going to increase the size here so that it fits our view. So we have selected the default view, and the size I'm going to choose here is automatic. So now we can drop our sheets one by one. First, let's drag the global cases sheet here. Okay, you can see we have our map. Now I'm going to choose the top 10 confirmed cases. Alright, and after that we'll choose the death cases sheet. So Tableau will prompt you to place the sheet at the right location. Okay, and now I'll choose my fifth visual, which is confirmed versus deaths, and if you want you can choose any one of these. Let's say I'll take the dual axis chart. Now you can just minimize the sheets and adjust the sizes to make it look better. Okay, so you can see here we have our dashboard ready. Now you can still go ahead and customize the dashboards in terms of adding different filters to it. We are not going to show that. Now you are getting some messages here, 2 unknown, 4 nulls. You can remove them as well, and here on the top you have the option to click on the presentation mode. There you go. So this is our final dashboard that we have created. Alright, so this brings us to the end of the second coronavirus data analysis project using Tableau. Now you can just click on escape to go back. Alright, now you can save this and this will be published in the Tableau public platform under your profile. So that brings us to the end of this video tutorial on COVID data analysis project using Python and Tableau. Welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC, so they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as NumPy, Pandas, Matplotlib and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first dataset. You can see on the top athlete_events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge dataset that we are going to use. The other dataset we are going to use in this demo is called NOC_regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. We have the region names. So AFG is for Afghanistan. You have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright, let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete_events.csv contains nearly 2,71,116 rows of information, and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. Alright. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two data sets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I have opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use NumPy, Pandas, Matplotlib, and Seaborn. Let me hit Shift Enter to import all the libraries. Alright. Now the next thing is to load the datasets using Pandas read_CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read_CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another /, and after that I'll give the file name, that is athlete_events.csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set. I'll create another variable called regions. So it will have my data frame. I'll use the same function pd.read_CSV. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc_regions.csv. You can verify here. The first one is athlete_events. The second one is noc_regions. Okay, I'll close the quotation. and we'll run it again. Okay, there seems to be some error. I think this is the regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes dot head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions dot head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second dataset. You have NOC, region and some notes. Alright. Now the next step is to combine both the datasets. So we'll join the data frames using the Pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes underscore df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the datasets is actually NOC. So I'm going to use the NOC column as my common column to merge both the datasets. Now let's go ahead and print the merged data frame. I'll say athletes underscore df dot head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added 2 more columns that were present in the second dataset, which was regions. So we have regions and notes added to my first dataset, that is athletes underscore events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last 2 columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt. I'll select athletes underscore df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows. So 2,71,116 rows, and earlier we had 15 columns in the first dataset, and now that we have added 2 more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes underscore df dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region. I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually. my second column, that is notes, I want to change the first letter to uppercase, so I'll say capital N. The rest all remains same. I'll give a comma here and say in place equal to true. So it will change the column names and will reflect in this athletes underscore df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last two columns, region and notes. Alright. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values and memory usage. So for that you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. Alright. Next, the describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile and the 75th percentile value of the columns ID, age, height, weight and year. Alright. Now one thing to notice here is, if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright. Now moving ahead. Now let's check if there are any null values present in the columns of the dataset. So first I am going to create a variable called nan values, give equal to, I'll say athletes underscore df, and the function to check is, I'll say is na. I'll create another variable called nan underscore columns, and here I'll use the any function. I'll say nan underscore this variable which is underscore values dot, I'll say any, and I'll print my nan columns variable. So this will display the result in terms of Boolean values. So if there are any null or nan or missing values in any of the columns, it will say true, otherwise it will say false. Let's display the result. There you go. So if you mark here clearly, so there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any nan or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. Let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, will use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year and everything. Alright, similarly you can also check for Japan. Let me just copy the above code, I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright, now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that I'll create a variable called top underscore 10 underscore countries. I'll say equal to, I'll use my data frame, that is athletes underscore df. I'll say dot team, then I'll use the function value underscore counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top underscore 10 underscore countries. Alright, Let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short underscore values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896. You have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot. Wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the x and the y-axis. So my x-axis has top. I should make this top 10 countries because above we used top underscore 10 underscore countries. Similarly for y-axis, I'll make it top underscore 10 underscore countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this, we are going to create a histogram. I'll be using the Matplotlib library specifically for this visualization. So I'll say plt.figure. We'll give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the x labels. I'll say plt dot x label. This will have age. Then we'll say plt dot y label, and this will have the label as number of participants. Next, I'm going to use the hist function. So I'll say plt.hist, and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function. So np is for numpy, and inside this I'll say 10, 80, 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the summer and winter Olympic Games. Let's look at the different sporting events that are part of the summer and winter Olympic Games. Just to give you a heads up, the winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter underscore sports, so I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the winter Olympics. Now similarly, let's see for summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer underscore sports, athletes underscore df remains the same. Here season we'll change it to summer, dot sport dot unique remains the same, and here I'll say summer underscore sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the summer Olympics compared to winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender underscore counts, which is my variable name. I'll use my data frame, that is athletes underscore df dot my variable name, that is sex, dot value underscore counts, and then we are going to print gender underscore counts. Let's run this. There you go. So since the inception of Olympics, we have more number of male participants than female participants. Now here in this current cell you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the Matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender underscore counts dot index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. Now you can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we're going to find the total number of medals that the athletes have won. So I'll use my data frame athletes underscore df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female underscore participants. I'll say equal to, and then use my data frame name, that is athletes underscore df. Using square brackets, I'll say athletes underscore df dot, the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column. So here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function. Say group by, which is part of the Pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index is a function, and finally we are going to print female underscore participants, and let's say the head. Alright, so what we are trying to do is, I'm trying to filter my data only for the female athletes for Summer Olympics, and here I am printing the participation based on each year, so I'm finding out the count. So here we need to add one more square bracket. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here. For the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics, we had 5,815 Olympics. Similarly, for the 2016 Rio Olympics, we had more participation than the London Olympics. So 6,223 women athletes had participated. Alright. Now here, this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female, and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid. Then my figure size I have given as 20,10. My count plot will have the x-axis as year. The data is Women Olympics, and palette I'm using as spectral, and then I have given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot, which says women participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis. Now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next, I'm going to say gold medals dot, all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have set gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I'll close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event. This is going to be my variable name, equal to, I'll use the same variable name gold medals. I'll going to choose my sport column, and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called Rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say, 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it. And if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years. And since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright. Now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals. Then we have Russia, Germany, UK, Italy, and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6, so it will give me the top 6 countries. Alright, now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team. Then I'll say team underscore names dot value underscore counts dot head, and will display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20, and Japan 17. Alright. Now using the above result, we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it, and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal, or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values, so we are not going to consider those null values here. We are only going to consider for the athletes who have won a medal. So for that, I'll create a variable called not underscore null underscore medals equal to, I'll say athletes underscore df, then I'll give my, let's make it df, I'll give my condition. Let me just copy this, I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis, I'll say athletes underscore df. This time we'll consider the weight column. Again I'll use the function as not null, and I'll close the parenthesis. Okay, I had missed one s here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure. I'll give my figure size equal to, I'll say 12, 10, I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma. In my y-axis I'll have weight, comma. My data should be not underscore null underscore medals. So this is what we created here, not underscore null underscore medals, comma. I'll use hue equal to my sex column. Cool. Finally, I'll say plt dot, I'll give a title to my plot saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Alright. So that brings us to the end of this video tutorial on Olympics dataset analysis. Indian Premier League, that is IPL, is one of the most popular and exciting events in world cricket. IPL 2022 will begin on 26th of March, so it's the best time for us and our viewers to learn about how to perform exploratory data analysis using the recently held IPL auction dataset. So in this video, all the results and insights that you will see are totally based on the data we have collected from Kaggle. We will leave a link to the dataset in the description of the video. You can go ahead and download it. For this demo, we'll be using Python and Jupyter Notebook to answer specific questions. So let's get started. We'll move over to our Jupyter Notebook. Okay, so I'm on my Jupyter Notebook and this is the file that we are going to use. So here you can see I have some of the cells already filled in. So this will save us some time and we can explore this data set in depth. So this is the file that I'll be using, or the IPython notebook. Cool. So first let's go ahead and import all the crucial libraries that will be needed for our analysis. So here you can see I am importing the Pandas library, the NumPy library. These are for data manipulation and numerical computation. Then we have Seaborn and Matplotlib for data visualization. Then I have imported this warnings module so that we do not get any warnings while running the code. Cool. So let me just hit Shift Enter to run the first cell. So here we will import all the libraries. Okay, it's done. Now the next step is I'm going to create a data frame in the name of IPL, and here I'm importing the dataset using the read_csv function, which is part of the Pandas library. So PD here has been imported as Pandas. I'm giving the dataset location followed by the name of the dataset. So here the name is IPL_2022_dataset.csv is the extension of the file. So let me go ahead and run this as well. Alright, so now we have successfully imported or loaded our dataset. Now the next step, let's go ahead and explore our dataset. So I'll use the head function for this, ipl.head. Okay, so here you can see the different columns. We have an unnamed column which is actually unnecessary for our analysis, so we'll see how to drop this column. Apart from that, we have the name of the players, the base price at which the player was sold, or whether the player was a draft pick. So here Rashid Khan from Afghanistan, Hardik Pandya, then we have Subman Gill. These are all draft pick, and then we have the price at which the players were listed in the IPL auction. Then we have the type of player, whether the player is a bowler, an all-rounder, a batsman, or a wicket-keeper. Then we have the cost in rupees. This is in crores. So basically this column tells us the price at which the player was sold in the auction. Then we have the price or the cost in dollars. After that we have 2021 squad. Basically this means in last year's IPL, where was the player? So here you can see Rashid Khan was playing for SRH, the Sunrisers Hyderabad, in 2021. But this year in 2022, he'll be playing for Gujarat Titans. Similarly, Hardik Pandya was playing for Mumbai Indians for past few seasons, including 2021. But this season is going to play for Gujarat Titans. So on and so forth. Now, let's see the total number of players that are present in the dataset and the total columns that are there. For this, I'm going to use the shape attribute. So I'll write ipl.shape. You can see here there are total 633 players that were part of the auction, and this includes the players who were draft pick also. And there are total 8 columns in my data frame IPL. Next, let's use the info function to check the columns, the data types, and the total non-null objects. So I'll say ipl.info, which is a function, so I have to use brackets. There you go. So here you can see it says total 633 entries from 0 to 632. Data columns, we have total 8 columns, and then these are the different column names, and here you can see the total non-null objects present in the column, and here you can see the data types, and at the bottom you can see the memory usage as well. Cool. Now the dot columns attribute will return the name of the columns in the dataset. So if I say ipl.columns and run it, it will give me all the different column names that are present in the data frame. Now as I said, the first column, which is unnamed :0, is actually unnecessary, so we are going to drop it. For that, we are going to use the dot drop function, and then I have passed in my column name followed by the axis, on which axis is it there, and then I say in place equal to true, which means it will replace and permanently remove the unnamed column from the data frame. So let's run it, and now we'll again check the head of the data frame. You can see before we had the unnamed column, which was the first column in the data frame, and now we have successfully removed it, so player becomes the first column in the data frame. Alright, now moving ahead, let's see the total number of null values that are present in each column of the dataset. So I'll say ipl dot, I'm going to use the isNull function followed by the sum function. If I run this, you can see here the player column doesn't have any null values. Similarly, base price and type column also don't have any null values, but you can see cost in rupees and cost in dollars have nearly 396 missing or null values. The reason being those players were not picked in the IPL auction, and hence there was no price associated. And then you can see there were a few players who were not part of the IPL squad in 2021, so those are being reflected as null as well. Now we'll check the rows that have cost in dollar as null or NaN. So here I have used IPL, and after that I'm passing in the column name which is cost in dollars, and then I've used the isNull function. If I run this, you can notice the cost in dollars column, all these values are NaN or null, and even the same rows have NaN for cost in rupees as well. Cool. Now the next task is to fill these null values or NaN values with zeros. So for that I'm going to use the fill NA function, and here I have passed in 0. So all the null values in the dataset will be replaced with 0 for cost in rupees column and cost in dollars column. Let me just run it. All right. Okay. Now we will see the players who were unsold in the 2021 auction, which means we will check the rows that have null values for the 2021 squad column. So what I'll do is I'll say IPL, within square brackets I'll say IPL, and then I'll pass in my column name which is 2021 squad, and then after this I'll say dot is null. So this cell will give us the unsold players in the 2021 auction. If I run this, you see here, you mark the 2021 squad column, all these players were unsold or did not participate, so hence it has NaN values. Alright. Now what we are going to do is we will replace all the null values that are present in the 2021 squad column with not participated. Like how we did in the previous example, we replaced all the null values with 0. Here we'll replace with a text value called not participated. So I'll say IPL, I'll pass in my column name which is 2021 squad equal to, I'll say IPL 2021 squad dot fill NA, which is the function, and here I'll pass in a text or a string saying not participated. Alright, let's run it. Before that, let me just scroll it down. Now I'll run it. Cool. Now that we have treated the null values successfully, let's verify it again. So I'll just say IPL dot is null, and then I'm going to use the sum function. If I run this, okay, this is also a function. Cool. Now if you see, we have successfully removed all the null values and replaced with either zeros or not participated, and hence now you can see none of the columns in the IPL data frame have null values, so it shows 0. Great. Now moving ahead, now we are going to add another column called status, which will hold two values, sold and unsold. But before that, we are going to slice our data frame. So here I am looking for all the rows where cost in rupees is greater than 0, and those should be unique, and I'm storing the value in a variable called teams. So here you can see we have the different teams where the cost in rupees is greater than 0. Now I'm going to create another column called status. So I have written IPL within square brackets. I'm passing in the column name which is status, and that will be equal to the team replaced by sold value. Let me just run it and show you the result. There you go. So here you can see we have added a new column called status, and it has values sold and unsold. If I just say IPL, at the bottom you can see the unsold values as well. Cool. Now in the next cell, we are going to check for duplicated players. So there are duplicate rows in the data frame, but here the names of the players are same, but in reality the players are different. So it is quite understood that different players can have the same name. So to get those names, I am using the duplicated function, and I'll say keep equal to false, which means I don't want to keep those players. Now let's run it. There you go. So here you can see Lalit Yadav, we have 2 entries. So Lalit Yadav here is an all-rounder whose base price was 20 lakh for 2022 IPL, and last year he was playing for the Delhi Capitals, and this year also he is sold to Delhi Capitals. Next we have Lalit Yadav, who happens to be a bowler. So this is again different Lalit Yadav. So last year he was unsold, and even this year he remains unsold. Similarly, we have Amit Mishra, who earlier used to play with the Delhi Capitals, but this time he remains unsold, so on and so forth. So you can see 2 entries for Subham Singh as well and Shivam Mishra. Alright. Now let's answer a very basic question. We're going to find out how many players have participated in the 2022 IPL auction. For that, we have already seen the total number of rows that were present, but again I'm going to use the shape function, and within square brackets I'm going to say 0, which means it will give me the total number of rows. And you can see 633 players were part of the auction. This is as per our data that we have collected from Kaggle. Up next, we are going to find how many types of players have participated. So I'm going to say types equal to, say, IPL. I'll use the column name which is type, and I'm going to find the count of each type of players that are present in the data frame. I'm going to use the values underscore counts function, and then I'll say types dot reset underscore index. If I run it, okay, there is an error here. Let me debug the error. Okay, so this should be value underscore counts, and the variable name is types and not type. So let's run it. You can see here we have the different types of players. So all-rounders, there are total 242 all-rounders who are part of the auction. Then we have 215 bowlers, 112 batsmen and 64 wicket keepers. Now using the above table that we just created, I'm going to plot my first pie chart. So for that I'm going to use the Matplotlib pie function. So plt.pie, I'm using types.values since I want only the values from this table, and then I'm saying labels equal to types.index. I've used a label distance of 1.2 to maintain some space, and then this is my format in which I want to print or show or display the percentage of distribution. I'm going to use shadow, so it says shadow equal to true, which is another parameter or an argument, and then I'm going to start my angle at 60 degrees, and here I have used a title called roll of players participated that will have a font size of 15, and finally I'm saying plt.plot. So let me just run it. There you go. So here we have a nice pie chart or a pie plot. So you can see the different pies here. We have all-rounder, wicketkeeper, batter and bowler. So majorly there are all-rounders in the auction, followed by bowlers. Then we have 17.69% batters and 10.11% wicketkeepers, which is the lowest. Cool. Now we are going to create another bar plot or a bar graph that will tell us how many players were sold and unsold. So for this I'm going to use a count plot. So we'll create two bars, one for sold and the other one for unsold, and each of the bars will have different colors. One will have orange, the other one will have pink, and I'm using labels. So to label the x-axis and y-axis, I have sold or unsold. Y label will have number of players. The title of my bar graph would be sold versus unsold. I've given a font size of 15 and I'm saying plt.plot. Now the function that you see here at the bottom will display the data labels for each of the bars. Let me just run it and show you the result. There you go. So I have used a figure size of 10,5. Alright, now you can see we have a really good bar plot which says there were total 237 players sold and 396 players were unsold as per the data we have. Cool. Now you can also print the total sold and unsold values. Let me show you how to do it. I'll say IPL dot, we can use the group by function, and I want to group it by status column, and the value that I want to measure is the players count. So I'll say players, rather player, and then I'm going to use the count function. If I run this, you can see here I've successfully grouped the unsold and sold players. The values are matching with the bar plot that we just created. So sold were 237 players and unsold are 396. Cool. Now we are going to see the total number of players bought by each team. Again, this is going to be a count plot, so basically a bar plot. So here the condition I'm passing is in the teams column the value shouldn't be unsold. So players bought means the value should be sold. So here I'm using this condition and the rest of the things remains the same. One improvement I have done here is I'm using x-ticks rotation equal to 70 degrees. This basically means the x labels would be tilted by 70 degrees. Now let's see the bar plot. There you go. So here you can see I have the title players bought by each team. On the y-axis we have the number of players, and on the x-axis you can see the values have been tilted by 70 degrees. Let me just zoom in so that you can see it better. And this is the bar plot. So the maximum a team can purchase is 25 players. Some of the teams have also purchased 24, 22 and 23 players. Let me just show you. So Gujarat Titans have totally purchased 22 players. Then Delhi Capitals have total 24 players in their squad. Again, Lucknow Super Giants have 22 players. If I scroll and see again, Bangalore Royal Challengers or RCB, the Royal Challengers Bangalore have 22 players in the team, and Rajasthan Royals and Sunrisers Hyderabad have 24 and 23 players respectively in their teams. Alright, now we will create 3 more columns called retention, base price and base price unit. For that, first of all, I am creating a new column called retention, which is equal to IPL base price. Let me just run it, and then I'm going to replace these values that are present in the list 2 crore, 40 lakh, 20 lakh, 1 crore, 30 lakh, 1.5 crore with from auction, and I'm saying in place equal to true. Let me just run it. Then we are going to treat the base price. So here in the base price column I'm going to replace draft pick value as 0. So let's run that as well. And now I'm going to split the base price value into 2 separate values called base price unit and base price. So basically I'm splitting on the space that I have. Let me show you how it is going to split. So this is, let's say, our base price column, what I did was I replaced the draft pick values to 0, and then the rest of the values will be split into two columns called base price unit. So basically it will have the unit of the base price, let's say crores or lakhs, and the base underscore price column will have the value, which is 2, here 40, 20, 20, so on and so forth. Let me just scroll down and run that particular cell. Now to create these two columns, the base price unit column and the base underscore price column, I have used the lambda function and I'm splitting based on the space. Let's just run it. Now I have replaced retained with 0, and let me show you the final data frame that I have. So here you can see we have replaced the draft pick values in the base price column to 0, and on the right side you can see the three different columns that I wanted to create. So one is called retention, so zeros refer to draft pick, any other value will say the player was picked from the auction. Then you have the base price unit, so here you can see crores, lakhs, and the value base price is 2, 40, so on and so forth. Cool.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's check how many players were retained and bought from the auction by each of the teams. So I'll say IPL, let me just scroll down, dot, I'm going to use the group by function, then I'll say team, comma, retention, then I'm going to use the value as retention because I want to find the count of retained players. Then I'll say colon -1. Let me run it. You can see here the different team names because I have grouped by team and then retention. So I have Chennai Super Kings. From the auction they had picked 21 players and they had retained 4 players. Coming to Delhi Capitals in the 2022 IPL auction they picked total 20 players and they have retained 4. Similarly, if I scroll down, let me talk about, let's say, Punjab Kings. They have picked 23 players from the auction and retained 2 players from the team last year. Talking about RCB or Royal Challengers Bangalore, they have picked 19 players from the auction and they have retained 3 players. Alright. Now in the next cell of code, we are going to display the players in each team based on the different types of players. So let me just run it and show you the result. So here I am using the same condition. The value shouldn't be equal to unsold, and I'm going to use another parameter called hue for the different colors. So here I have used hue as type because I want to show the players in each team based on the different types. Again, I have given my title to the bar plot, and then I have the X label, the Y label, and my rotation is 50 degrees now. If I scroll down, you can see the different types of players. Here is the legend. So blue is for bowler, orange or yellow is for all-rounder, green is for batter, and red, which also looks like maroon, is for wicket keepers. And on the x-axis you can see the different team names. Alright, now let's answer another couple of questions. So here I have, what is the highest amount spent on a single player by each team? So to solve this question, I'll say my data frame name, that is IPL. Then I'm going to say retention equal to this should be from auction, because we want to see the highest amount spent and not from the retained players. Then I'm going to group by, I'll say team, and then I'll say cost in, let me just copy it from here, cost in rupees, that is in crores, and I'll say max colon -1 dot sort underscore values, I'll say ascending equal to false, which means I want the sorted result in descending order. Okay, let me just bring this to the left side and we'll run it. There seems to be some error. Let me check the error. It says there's a spelling mistake. This should be team. Let me run it again. There you go. So you can see Mumbai Indians have spent 15.25 crores for one of the players, and this player happens to be Ishan Kishan. Then Chennai Super Kings have spent the highest amount for a player who happens to be a bowler. The name is Deepak Chahar. They have bought him for 14 crores. Kolkata Knight Riders bought Shreyas Iyer for 12.25 crores, and so on and so forth. So these are the highest amounts spent on a single player by each of the teams. Let me scroll down. Now we are going to see the player retained at maximum value or maximum price. Now if you follow IPL, the maximum price at which a player was retained happens to be Ravindra Jadeja. So let's see at what price was he retained. I'll say retention equal to I'll say retained, then I'll say sort underscore values by equal to, I'll use the same column, cost in rupees, that's in crores. I'll say ascending equal to false dot head, and I want to find the top player. Again there's some error. Let's see where is the error. It says ascending equal to false dot head. Okay, this should be sort underscore values, within bracket I should say by. I think this should be fine now. Let's run it. There you go. So you can see here our result is player name Ravindra Jadeja, who was retained for 16 crores by Chennai Super Kings. Cool. Now the next cell of code will display or print the top 5 bowlers who have been picked in this year's IPL based on their cost in INR. Let me just run it and show you the result. You can see here Deepak Chahar went for 14 crores. Then we have Shardul Thakur, who was bought by Delhi Capitals. Earlier he was part of CSK for 10.75 crores. Then we have Prasidha Krishna, who has been bought by Rajasthan Royals this time. Last year he was with KKR and he has been bought for 10 crores. Similarly, Lockie Ferguson has been bought by Gujarat Titans and he played for KKR last season. He has been bought for 10 crores while his base price was 2 crores. Then we have Avesh Khan, can see Avesh Khan's base price was just 20 lakhs and he has been bought for 10 crores by Lucknow Super Giants again, and last year he was part of the Delhi Capitals. Now you can replace this value. Suppose let's say you want to find the top 5 batsmen picked or batters picked with the highest amount. You can just say batter instead of bowler, and if I run this, you can see here Shreyas Iyer was bought by Kolkata Knight Riders for 12.25 crores. Last year he was part of Delhi Capitals. Then you have Shimron Hetmeyer, who's from West Indies. He has been picked by the Rajasthan Royals for 8.5 crores. Then we have Rahul Tripathi, Shikha Dhawan and Devdutt Padikkal. Now if you wanted to check for, let's say, all-rounders, you can replace batter with all-rounder. If I run this, you can see Liam Livingstone has been bought by Punjab Kings this season for 11.5 crores. His base price was just 1 crore, and last year he was part of the Rajasthan Royals. Then we have a player from Sri Lanka, Hasaranga. Then we have Harshal Patel, Shah Rukh Khan and Rahul Tewatia, who have been the top 5 all-rounders picked at highest amount. Cool. Now finally, we want to see the players who were part of the IPL last season but were not picked for this year's IPL. So for that, what I'm doing is, first I'm renaming my 2021 squad column. This column I want to rename it as previous team. Let's run it. Then I'm going to find out the unsold players. So here I'm saying previous team not equal to not participated, and then I'm using another condition. The team should be equal to unsold, and I'm going to find out only the player and the previous team. So let's run it and see the result. So here you can see these players were part of the IPL last season, but they haven't been picked this season. And last season they had played for, let's say, Suresh Raina played for CSK, Steve Smith was part of the Delhi Capitals, Saqib Al Hasan was part of KKR. If I scroll down, you have David Malan, who played for Punjab Kings in 2021. Owen Morgan, who played for KKR. He also captained KKR, but unfortunately he was not picked this season. Chris Lynn from Australia also remained unsold this season. Andrew Tye, we have Ben Cutting, Aditya Tare. There are other players as well. We have Kane Richardson, Dhaval Kulkarni. Cool. So these were the players who were part of the IPL season 2021, but unfortunately were not picked and remained unsold for 2022 season. Cool. And that brings us to our end of this demo session on IPL Data Analysis 2022. So we learned how to use the different functions and attributes that are part of the Python libraries, and we manipulated the data, we visualized the data and answered some specific questions. In this video, we'll be using 4 publicly available datasets about Formula 1 that has information from 1950 to the 2019 F1 season. We'll see how using the Python libraries you can perform exploratory data analysis and draw valuable insights. So let's begin by understanding what Formula 1 is. Formula 1, also known as F1, is a motorsport defined by open-wheeled single-seat race cars. It features the best drivers in the most powerful and technically advanced cars. The sport is governed by the FIA, that is International Automobile Federation. Here 10 teams comprising of 2 drivers each compete in a series of races over a period of 1 year to find out the ultimate driver and a constructor champion. In our demonstration, we'll be using 4 datasets. Let me show them one by one. These are all CSV files. Now this is the first dataset that we'll be using in our demo. So if you notice, the dataset does not have column names. In fact, none of the datasets have column names. So while importing the dataset, we'll assign the column names using the names parameter. I'll show that in a while. Now this is the results dataset. The results dataset has information about the result ID. Then we have the race ID, driver ID. We have the constructor ID, grid, position. Then we also have information about the fastest lap. Then we also have information about rank, the fastest lap speed, and the status ID. Now moving on to the second dataset, which is about races. Now this is the second dataset, which is about races. So it has information about the race ID, the year in which the race was held. Then we have the round number, circuit ID, then the name of the Grand Prix. So you can see here Australian, Malaysian, Chinese, Spanish, Monaco, Turkish, British, German, and others. Then we have the date on which the GP was held or the Grand Prix was held. We have the time and a URL which basically leads to the Wikipedia page of that particular Grand Prix for that year. Now moving on to our third dataset. So this is our third dataset, which is about drivers. Now it has the driver ID, the name of the driver. You can see here Hamilton, Rosberg, Alonso, Raikkonen. Then we have Sato, Massa, Button, Weber, and all. After that, we have the number code. Then we have the forename of the driver, the surname of the driver, and then we have the date of birth of that particular driver. We have the nationality as well. And we have the Wikipedia page for the driver. Now moving on to the last dataset, which is about constructors. So this is the fourth and the final dataset that we'll be using in our data analysis project. So here we have the constructor ID, then the constructor reference in Formula 1, and this is the actual name of the constructor. So we have McLaren, we have BMW Sauber, Williams, then we have Ferrari, Toyota, Red Bull, Force India. We also have Jordan, Jaguar, and all. Next, we have the nationality and the URL, that is the Wikipedia page of that particular constructor. Now let's head over to our Jupyter notebook and we'll start with our analysis. Here is my Jupyter notebook that I'll be using for this demo. You can see some of the cells are already filled. This is just to make sure we save some time. So using these datasets that we just saw and our libraries such as NumPy, Pandas, Matplotlib, and Seaborn, we'll answer specific questions such as the drivers and constructors who have been the most successful throughout the history of F1 sport. Then we'll explore the impact of starting and finishing positions and if the speed of the cars has changed over the years. So let's begin with our analysis. First and foremost, we are going to import all the necessary libraries. So here I'm importing NumPy, Pandas, Matplotlib, and Seaborn. And after that, I'm writing %matplotlib inline. That is to ensure that all the plots are embedded inline. I'll hit Shift Enter to run it. It'll take some time. There you go. So we have successfully imported all the libraries. Now the next step is to load the data and assign column names. So I'll load my first data, which is results. I'll say pd.read_csv. I'll give my file name, which is results.csv. And then using the names parameter, I'll pass in the column names. So actually I have written the column names in a notepad. Let me open that. So I have this F1 notepad created which has the column names. I'll just start copying the column names. Within the names parameter, I'll paste it. If I scroll to the right, you can see the different column names that have been assigned. And after that, I'm going to say comma, and I'll write header equal to none. I'll close the bracket. Cool. Similarly, let's import the second data set, which is about races. I'll say pd dot read underscore csv. I'll give my file name, which is races dot csv, and then I'll give the names parameter. This is actually names and not name. Okay. I'm going to copy the second line and I'll paste it here, and again I'll say header equal to none. Next, we'll import our third data set, which is about drivers. So I'll say pd dot read underscore csv. I'll say drivers dot csv, and then again use the names parameter, and I'll copy the third line now, which has the column names for the drivers dataset. Here I need to give another parameter, which is header equal to none. Finally, we are going to import our constructors dataset. We'll say constructors equal to pd dot read underscore csv, which is the function present in the Pandas library. I'll say constructors dot csv, which is my file name, and then again I'll use the names parameter. I'll go to my notepad, and this time I'll copy the fourth line, which has the column names for the constructors dataset. I'll paste it, and here I'll give my final parameter, that is header equal to none. Alright, now let me hit shift enter to run it. Okay, we see some error here. Let's debug the error. It says no such file or directory drivers.csv. Let's see where was the issue. Okay, this should be driver.csv. Cool. Now we have successfully loaded the data and assigned the columns to the various data sets. Now the next analysis is to merge all the data set. So here I'll create a data frame called df, and I'll use pd dot merge function. First I'll use the results data frame that we just imported above, this one, and I'm going to merge it with races data frame, and from the races data frame I'm going to take specific columns like the race ID, then I need the year, after that I need name. Next I'm going to take the round column as well, and I'm going to use on parameter. So on parameter is actually the column that is common to both the data frames, that is results and races. So here my common column is going to be the race ID because it is present in both the data sets, and I would like to merge. So for that I'm going to use how. So I'm going to use a left join. So if you know SQL, you will be aware of left join. It takes all the rows from the left table and only the matching rows from the right table. Again going to use the merge function, so I'll write df equal to pd dot merge. I'll say df comma, and now I'm going to merge the drivers dataset, and I'm going to select specific columns. So I'll say driver ID. Make sure there are no spelling mistakes in the column names. Then I'll say driver ref, which is the name of the driver or reference, comma, and then I want the nationality of the driver. All right, I'll give a comma. I'll say on which column I want to merge. So here the common column is going to be the driver ID. Again, how is going to be a left join. Going to the final merge part, I'll say again df equal to pd dot merge. I'll pass in my data frame, and my final data set which I have is about constructors. From constructors we are going to choose specific columns, so I'll take the constructor ID, then I'll take the name column, and again the nationality column of the manufacturer. Here I'll say on equal to the common column I'll use is constructor ID. Give a comma and say how equal to left again. Cool. Make sure you're merging it with the right column names. So let's run this cell to merge all the 4 data sets. I'll hit Shift Enter. Oops, there is some error. Let's see. It says constructor ID index. Okay, there's a spelling mistake. This should be constructor ID. Cool. Let's run it. There you go. Now the next thing we want to do is to drop the unnecessary columns. So I'll say df dot drop. Within the drop function we are going to pass in the column names. I'll say number. Then we also don't want the position column. Next we have position underscore text. After that we have laps. Next we are going to drop fastest lap. Then we'll also drop the status ID, comma, we'll drop the result underscore ID column. Then going to drop the race underscore ID column. We'll also drop driver underscore ID column, and finally we are going to drop the constructor underscore ID column, and I'll say access equal to 1, and in place I'll say equal to true because I want to remove it from my original data frame, that is df. There you go. Now the next thing I want to do is I want to rename some of the columns. So I'll say df dot rename. I'll say columns equal to, now we are going to pass in a dictionary. I'm going to change the rank to test underscore lap underscore rank. Let me give a comma. Now I'll say name underscore x. equal to, I'll say the Grand Prix name, so I'll say GP underscore name. Next column I'm going to focus is the nationality column, so I'll say nationality underscore X. I'll give a colon. The value I'm going to pass in is driver nationality. Alright. Up next, we have one column called underscore Y, and that I'm going to change it to constructor name. Another comma, I'm going to say nationality underscore Y colon, change it to constructor nationality underscore nationality. Finally, we have driver underscore ref column, and that I'm going to replace with just driver. Finally, I'll say in place equal to true. Cool. Just verify if all the column names are correct. Let's run it. Alright, so now we have successfully renamed the columns. After that, in the next cell, I'm going to rearrange the columns. So here I'm using the same data frame and we have just renamed the columns. So starting with year, Grand Prix name, round, driver, nationality, and others. Let's run this. Up next, we're going to drop the 2019 season data because it is incomplete. So I'll say df equal to df, then I'll say year not equal to 2019. Let's see how to sort the values. So I'll say df equal to df dot sort underscore values, which is the function name. I'm going to sort it by year followed by round followed by the position underscore order, comma, I'll say ascending equal to, first let's say is false, next I have true, and then I'll have true. Alright, moving ahead, now we are going to see how to replace the /n values in the time column with something called NaN, because the time column was not registered when a driver did not finish a race or was lagged by another driver. So to do this, I'm going to say df dot time dot, I'm going to use the replace function, and here I'll say / or /n, and I'm going to replace with NumPy's NaN. I'll say in place equal to true. Let me just copy this because we are going to use the same meters. Next, I'm going to replace the milliseconds value milliseconds dot replace. I'll paste it here. Then I'll say df dot fastest underscore lap underscore rank dot replace. Paste it. Next I have df dot fastest dot lap dot time. Say replace. To that I have the next column, which is speed. So I'll say fastest underscore lap underscore speed dot replace. I'll paste it. So here I'm going to replace this particular value, the backward slash n, with nan. Let me run it. Cool. Step, I'm going to change the data types for fastest underscore lap underscore speed to float, then fastest underscore lap underscore rank to float again. Now problem here is we cannot convert it into an integer because there are missing values, so we are going to change it to float. Again, for milliseconds also we are changing it to float values. Let me run it. Now I'll reset the index. Let me show you how to reset the index. I'll say df dot reset underscore index. I'll say drop equal to true. I'll give a comma and say in place equal to true. All right. That we have done our initial processing step of the data set. Now we'll check the shape of the data set. Then we see all the data sets, the total number of non-null values, the memory usage, and we'll check the head of the data set. Now to see the total number of rows and columns, I'll say print df dot shape. You can see here there are total 24,197 rows in my data set, and there are total of 15 columns. Now let's use df dot info function. So it gives me the year, the Grand Prix name, the round number, driver, constructor name, grid, position order, total number of points, time, then time in milliseconds, the fastest lap rank, the fastest lap speed, the nationality of the driver, the nationality of the constructor. Then here we have the total number of non-null objects, and then you also have the memory usage at the bottom. Finally, let's see the head of the data frame. So I'll say df dot head. Let's say I want to check the first 10 rows. There you go. If I scroll down, you can see here we have the top 10 rows printed, and you have the year, the Grand Prix name, round, driver, constructor name, and other columns. Now let me just brief you about what these column names stand for. So the year column that you see here is the season that the Grand Prix took place, and then we have the name of the Grand Prix. Now the round column is the number of the race in each season. For example, 1 means it was the first race of the season, and then 2 means it was the second race of the season, so on and so forth. Then we have the name of the driver. For that we have the name of the car constructor, so you can see Ferrari, Mercedes, Red Bull, Renault. Then we have the grid, that is the starting position before the race. Actually this depends on the qualifications which occur 1 day before the race. Then we have the position underscore order column. This means the final position at the end of the race. Then we have the points column, that is the total number of points scored in the race. Next we have the time, that is the amount of time that took to finish the race. Only the winner's time is displayed and drivers behind the winner are shown how far behind the winner they are. Then we have the milliseconds column, that is the amount of time that took to finish the race in milliseconds. If I just scroll down, I'll just move to the right, go to the top. Then we have the fastest underscore lap underscore rank, that is the order of the fastest lap during a race. Next we have fastest lap time, that is the shortest amount of time that took to complete a lap in the race. Then we have the lap speed, that is the average speed of the fastest lap. Then we have the country to which the driver belongs to, and then we have the constructor nationality, that is the country where the car constructor is based out of. Okay. Now here I'm going to set my figure size to 10,6. This is going to be for all the plots that we are going to create afterwards. Cool. Now, we'll create a data frame that will have all the Grand Prix winners. So here I'm going to say driver underscore winner equal to, use my data frame df dot, I'll say loc, then I'll say df, I want the position underscore order, and that should be equal to 1, so which means the driver won the race. And then I'm going to use the group by function. I'm going to group it by driver, and for values I'll say position underscore order, use the count function followed by sort underscore values. I'll say ascending equal to false. Change it to 2 underscore frame dot reset underscore index. What essentially I'm doing here is I am finding out all the drivers that have participated and won a Grand Prix. Next, I'm going to create a bar plot. So this is going to be the first visualization of our analysis. So I'll say SB, which we have taken in our analysis. Ideally it should be SNS, but SB also will work. So I'll say SB dot bar plot. I'm going to say data equal to driver underscore winner. In the y-axis I'll have driver. In the x-axis I'll have position underscore order. Then I have color equal to green, that I'll set my alpha value to 0.5, or let's say 0.8. Then we are going to give a title to our plot. So I'll say plt dot title, let's say most Grand Prix winners in F1. Then we are going to label our axis. So for y label I'll have driver name. We have the x label, that will have number of Grand Prix wins, and I'll say plt dot y ticks. Let's run it, and you can see we have our first bar plot here. Now the bar plot shows that there are a large distribution of Grand Prix wins. Only a few drivers in history of F1 have won over 20 Grand Prix in their careers, and there are some drivers who completely dominated the F1 racing and have won over 50 Grand Prix in their careers. So we are going to focus on those top 5 or top 10 drivers in the next section. So what I am doing here is, from the above result that we just got, I'm going to filter out only the top 10. So I'm going to use the head function, and inside that I passed in 10. If I print it, you can see here, as per the data that we have Michael Schumacher, who is the position order leader with 91 GP wins. Then we have Hamilton, Vettel, Prost, Senna, Alonso. Then we have Stewart, Clark, and Lauda. The data that we have is not the most recent one. So if you check the actual stats, Hamilton has actually overtaken Michael Schumacher and has won over 103, close to 103 races as of now. And next we have Michael Schumacher. So this is not the most recent data. Cool. Now using this data, we'll create another bar plot for the top 10 drivers. So I'll say sb dot bar plot. I'll say data equal to the name that we have used, that is top 10 drivers. So I'll say top 10 drivers. In the y-axis we'll have the driver name. In the x-axis we'll have position underscore order. For the bars, I'm going to use a color equal to, let's say, blue this time. I'll set my alpha value to be 0.8, and I'll say, let's say, line width equal to 0.8, and I'll also give an edge color of, let's say, black. Cool. Follow the same drill. I'm going to give a title to my plot. So I'll say plt dot title most GP winners in F1. We'll give a y label that says driver name, and then I'll have x label which will have number of Grand Prix wins. Cool. Let me see if everything is fine, and then we'll run this. There you go. You can see we have a very nice horizontal bar plot that shows the top drivers in F1. So as per our data that we have Michael Schumacher, who has won over 91 or close to 91 races. Then we have Hamilton, Vettel, Alonso, Clark, and others. All right. In the same way, we are going to create bar plot for the top constructors that have participated in F1. So here I'm finding out all the constructor winners. So here I'm using my position underscore order equal to 1, and then I'm using the group by based on the constructor name, and then I'm finding the count of position order and sorting the values in descending order, and I'm changing it to frame or to a data frame. And to create my bar plot, I'm using the bar plot function, the data which is constructor underscore winner. In the y-axis I'll have the constructor name. On the x-axis, I'll have the position order. So you can see here I've used color as pink and I've given a title, x label, y label, and y ticks. Let's run it. There you go. So here you can see again the data is widely spread. So we have a lot of constructor names. Now our next task is to check the top 10 GPA constructor winners. So here I'm using the head function and finding out the top 10. If I run it, you can see here the manufacturing companies or the constructors who have won the most number of races are Ferrari, McLaren, Williams, then we have Mercedes, Red Bull, Team Lotus, Renault, and others. Okay, now we'll convert this data into a horizontal bar graph or a bar chart. So that will show the bar plot for the top 10 constructors. Now let me show you how to do it. So I'll say SB, which is for Cbond dot bar plot. I'm going to say data equal to top 10. Let me just confirm the name. We have top 10 constructors. Scroll down. I'll say constructors. The y-axis, I'll have constructor on the x-axis, I'll have position underscore order. Then I'll say color equal to, let's say we'll use the red color for the bars. Then I'll set my alpha to 0.8. I'll say line width equal to 0.8 and my edge color I'll say black. That I'll say plt dot title, say top 10 most GP wins. Plt dot y label would be constructor name, and I'll have plt dot x label as number of GP wins. Cool. Let's run it. There you go. So here you can see we have Ferrari at the top, then we have McLaren, Williams, Mercedes. I'm pretty certain by the end of 2021 season, Mercedes would have gained a lot of wins since Hamilton has been on the top for Mercedes for quite some time now. All right. Now, finally, we are going to create a regression plot that will show how two variables, that is the starting position and finishing position, vary. So to do that, I'm going to exclude the data points with grid 0 because it skews the data. So 0 means that the driver started from the pit lane. So I'm using this function called regplot to plot my regression line. Let me run it and show you the result. There you go. So if you see here, we can easily see there's a linear relationship between the starting and finishing position. So on the x-axis we have the starting position, on the y-axis we have the finishing or the finished place. So which is what is actually expected, right? Now we can also see that most races had up to 25 drivers. You can see the density of the points here, but some of the races also had over 30 drivers. You can see the light color blue dots. Next, we are going to check whether the speed of the cars changed over the years. Now, since this data is only available from 2004 onwards, so we have taken years that start from 2004 onwards. Now let me show you the result of this data. So essentially we are plotting the average speed amongst all teams during the fastest lap at individual Grand Prix, and here on the y-axis you have the average fastest speed in kilometer per hour, and then you have the different GPs, and you can see here the year values. Now in general what we see is there's a decrease in the average fastest lap from 2004 till around 2015 for almost all the circuits, and again from 2015 onward the speed started to increase. You can see here there's an increase after 2015, there's an increase here as well. You can also notice that the speed is very different on each track. For instance, if you check the Italian Grand Prix, which is here, Italian GP has the fastest race in the calendar with average speed exceeding over 240 kilometers per hour. On the other hand, if you talk about the Monaco Grand Prix, let me show you. If you see here, the Monaco GP is the slowest race with average speed below 160 km per hour. Now this is actually expected because the Monaco Grand Prix has very narrow streets and hence the drivers cannot drive fast in this circuit. Alright. Hello everyone. Welcome to this live session on SQL full course video by Simplilearn. In this video, we will learn everything to master structured query language or SQL. This full course video will help you write SQL commands using MySQL, PostgreSQL as well as SQL Server. Our highly experienced trainers will take you through this course, but before we begin, make sure to hit the subscribe button and stay updated with all the latest tech videos. So we will start by learning the basics of SQL along with understanding entity relationship diagrams. Then you will learn how to install MySQL Workbench on Windows. We'll look at the popular SQL commands to select, insert, update and delete records and perform other operations on database tables. You will see how to use the top numerical and text functions in SQL. Next, we will cover how to use group by and having in SQL followed by joins. So you will learn the different types of join statements as well as subqueries in SQL. Moving further, we will understand triggers, stored procedures and window functions in MySQL. You will get an idea about another important topic, that is to write SQL queries with Python on Jupyter Notebook. Then we will look at another free and open source relational database management system, that is PostgreSQL, with extensive hands-on demonstration. Finally, you will learn how to become a SQL developer and see the top SQL interview questions that are frequently asked in the interviews. So let's get started with what is SQL. In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL Server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed and updated. You can organize data into tables, rows, columns and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server, Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here each row represents a record or a tuple. So you have the player ID, which is 103 here, the name of the player is Daniel, he is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access. In this session, we will learn about ER diagram, starting with what is an ER diagram and why it's been so much used by the companies. Then we will learn about the symbols used in the ER diagram and get familiar with the components of it. So hey everyone, I'm Abhisar Ahuja from Simplilearn and welcome to this video on ER diagram in DBMS. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. Let's start. Have you ever wondered how these big e-commerce companies manage their tons of data that keeps updating every second? And these datasets keep on updating in their databases. To perform operations on this data, they should have a conceptual understanding of these databases. And this is done by understanding ER diagrams of the databases. So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and the relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram. Starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent their relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. when a single element of an entity is associated with a single element of another entity. This is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, this varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have are basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types, and operators that we just learned.
In this session, we will learn how to install MySQL Workbench and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we'll move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL Server, MySQL Shell, and the MySQL Workbench. Expand MySQL servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL Workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL Shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click next. Now we'll configure our SQL Server instance. Here we'll go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on next. And here also we'll keep the default settings and click on next. Now to apply configuration, we will execute the process. Once all the configuration steps are complete, click finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on finish. Now the shell and workbench has started. Now we'll connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we will reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL, MySQL Server 8.0, bin. And now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started, and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL 80 and enter the password to connect to the local host. The MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now, there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns underscore prive, component, db, and much more.
Now let me now go ahead and open my MySQL Workbench. So in the search bar I'll search for MySQL Workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL Workbench, and below under connections you can see I have already created a connection which says local instance. Then you have the root, the local host and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL Workbench looks like. Here we learn some of the basic SQL commands. So first let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon, and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database and I'll name it as SQL intro. So the command is create database and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL intro. If I scroll down, there you go, you can see the name here, SQL intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL intro database. So I'll use the command create table and then I'll give my table name, that is going to be employee_details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city and salary. For each of the columns we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp_details. If I run this, there you go. So under field you can see the column names, then you have the data types, null represents if the table can accept null values or not, and these are basically empty, and we haven't set any default constraint. Alright, moving ahead. Now let's learn to add data to our table using the insert command. So on a notepad, I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values, I have passed in all the records. So first we have Jimmy, which is the name of the employee. Then we have 35, which basically represents the age. Then M means the gender or the sex. Then we have the date of join. Next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, this Dwayne, Sarah and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case, you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that, I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is emp details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin and New York. Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum, and since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this, this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum, you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here. This says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case you can use the OR operator. Now the OR operator in SQL displays a record if any of the conditions separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause, where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause I'm going to write where city and use the in operator. Inside bracket I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details, where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000, and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here, who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table, where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like, for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary, as I'll give an alias name, let's say total salary, from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details, and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India, and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it is converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright. And this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learned about group by, order by and some basic SQL operations. Now it's time to explore some string functions in MySQL. So I have given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now, instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu_name and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. It is not readable actually. Let me also display these student names so that we can compare their length. Alright, I'll run this again and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as, let's say, name_age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name underscore age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is, let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4 and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6 and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5 because India is total 5 characters long and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place or at the 13th position we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. In this session, we are going to learn two important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement and then followed by the column names that we want to select. From, we have the table name followed by the where condition, and next we have the group by clause, and here we include the column names. Finally we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to. And then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department and then we are using an aggregate function, that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name, which is average underscore salary, which appears in the output. You can see here from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench, where we will implement group by and solve specific problems. Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query, that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer and I'll assign employee ID as my primary key. Next, I'll give employee underscore name and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join and the data type will be date. We have the department column as well. This is going to be of varchar and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information. And now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned and here are the department names. So we have sales, marketing, product, tech, IT, finance and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select avg, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says avg of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places, so I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright. Now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma. Now I want the total salary, so I'll use the sum function, and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next, we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 1 to 1 and let's say 1 to 3, since we have just 2 product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the 2 product IDs 1 to 1 and 1 to 3, and here you can see the revenue that was generated from these two products. Alright, now let's say we have to find the total profit that was made from both the products, 1-1 and 1-3. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 1-1. Let's say the cost price was $270 for each, and next we have my product as 1-3, and let's say the cost price for product 1-3 was $250. Let's insert these two values. Okay. Next we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 1-1, we made a profit of $1,100, and for product ID 1-3, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function, that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause I'll use my condition, that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function, and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I am going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on my SQL workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL workbench 8.0 version installed. I'll click on it. So it will take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Control Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay, now to understand inner join, consider that there is a college and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket_ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column, followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this, I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case, you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c.name is equal to f.name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson, and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay, now let me just show the different tables that are part of classic tables. Alright, so here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products, and product lines as well. Alright, so let me use my select statement to show what are the columns present in the products table. Okay, so this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price, and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright, now suppose you want to find the product code, the product name, and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description, so I'll write this column name. Okay, then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes. Then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join three tables, that is orders, order details, and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product. We have the price of each product. Then we have the order line number. Okay. So using the product, orders, and order details, let's perform an inner join. So I'll write select O dot order number, comma O dot status, comma I need the product name, which I'll take from the products table. So I'll write P dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD. On, I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are 2 address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O, on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing. There are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name, there were no orders. And similarly, if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169, there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here, I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on E dot, my common key column is employee number here, so I'll write E dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056 the manager is 1002. So if you check for 1002 we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102 the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188 we have the manager as 1143. Now if I check the table at 1143 we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot. I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write c dot customer name. So for this example, I'm using the customer table and the order table, comma o dot order number. So I just want to know the customer name and the order number related to the customer. From I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright. So that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next, we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join. In this video we will learn what is a subquery and look at the different types of subqueries. Then we learn subqueries with select statement followed by subqueries with insert statement. Moving further, we will learn subqueries with the update statement, and finally we look at subqueries with delete statement. All this we will be doing on our MySQL workbench. So before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete, and insert statement. We'll explore each of this with the help of example on my MySQL workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is subqueries. You can see it here. I have a database called subqueries. So I'll use this subqueries database, and we'll create a few tables as well. Okay, now if I run it, now we are inside the subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department, and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city, and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department, and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the avg function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data written from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual columns or star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright, so we are going to write this query on my MySQL workbench. So let's do it. I'll give my comment as update subquery. Alright, so first of all let's create a table that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it. Okay, so we have successfully created our products table. Now let's insert a few records to our products table. So I'll write insert into products followed by values. I'll give 4 records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800, and the product type is, it's a luxury product. Next let's insert one more product detail. The product ID is 102. The product is, let's say, t-shirt. The price is, let's say, $100, and the product type is non-luxury. Next I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300 and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400 and it's a non-luxury product. I'll give a semicolon and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now we need to create another table where we are going to put some records from our products table. So that new table is going to be the orders table. So I'll write create table orders. Now it will have 3 columns. The order ID will be of type integer. Then we have product underscore sold. This will be of type varying character of size 30, and finally we have the selling price column. This will be of type float. Let's create our orders table. The table name should be orders, and there is some mistake here. Okay, you should close the brackets. Okay, let me run it. So we have our orders table ready. Now let's write our insert subquery. So I am going to insert into my table, that is orders, and I'll select the product ID, comma, the item and the selling price or the sell price from my table, that is products, where I'll write product ID in, I'll write my inner query select prod ID or the product ID from products. Next, I'll give a where clause where the selling price is greater than $1,000. So let me tell you what I am going to do here. I am going to insert into my orders table the product ID, the item name and the selling price from my products table, where the product ID has this condition. So let me first run this condition for you, which is select prod ID from products where the selling price is greater than 1000. If I run this, okay, there is some issue here. The column name is actually prod ID. Now let's run it again so that we can see the product IDs of the products which have a selling price greater than 1000. So it is 101 and 103. Now let's run the entire query. There is another mistake here. Let's debug the mistake. Now this should be product ID instead of product underscore in. Let's insert again. Alright, so we have successfully inserted 2 records to our table, that is orders. Now let's see the orders table. I'll write select star from orders. If I run it, there you go. So there were 2 products from our product table that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees underscore b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees underscore b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees underscore b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees underscore b, where age is greater than or equal to, let's say 27. Alright. So let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking if the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than or equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore B, where age is, let's say, greater than or equal to 32, or let's say the age is less than or equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than or equal to 32. So we are going to delete the records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than or equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use 2 tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than or equal to 27. And finally, we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than or equal to 32. In this video, we will discuss an advanced SQL concept called triggers. We will learn what triggers are and how they can be used to solve problems. We'll look at how trigger queries are written on MySQL Workbench. So let's get started. First, what are triggers in SQL? So a trigger is a user-defined SQL command that is invoked automatically when an event occurs. An event can be related to inserting, updating, or deleting records in a table. In MySQL, triggers can be executed automatically by the Oracle server. Below is how the syntax of writing a trigger is. So you write create trigger followed by the trigger name. Now the trigger name should be a valid SQL name. Then we have the trigger time, the trigger event, and then on the name of the table. Then we write for each row begin followed by the list of SQL statements, and finally we write end. Now in the syntax, the trigger time represents either before or after an event, and a trigger event can be an insert, update, or delete operation. Now let me take you to MySQL Workbench, where we will learn how to create triggers and explore more on how it works. So I am on MySQL Workbench. So first let me go ahead and create my connection. I'll give my password. Alright, now this will take you to my SQL editor. Okay, so first and foremost, let me create a new database called triggers. So I'll write my SQL command as create database triggers. Let me run this. Okay, so you can see here one row affected. I have created my database, that is triggers. Next, I'm going to move inside this database, so I'll write the command use triggers. Let's run this. Okay, now inside this triggers database, we'll be creating our different tables. So let's check if we have any tables. I'll use the command show tables. Now you see there are no tables in this database. Alright, first let's see how before insert trigger works. So for before insert trigger, we'll create a table called customers and verify the age of each customer. So I'll give a comment before insert trigger. So let me go ahead and create my customers table. I'll write create table customers, and I'll give my column names as cust_id, which is customer ID. This is going to be an integer. Then we have the age of the customer. This is again an integer, and we'll have the name of the customer. The name of the customer will be of varchar type. I'll give the size as 30. Alright, let's create this table. Okay, so we have successfully created our customers table. Now moving ahead, I'm going to write my before insert trigger command. So we'll start with a delimiter. So a delimiter is a marker for the end of each command. Next, I'll write my create trigger followed by the trigger name. I'll give a valid trigger name such as age_verify. I'll write before trigger. It should be before insert on. My table name would be customers. Then I'll write for each row if new dot age is less than 0, then set new dot age equal to 0, which means while inserting your values to the age column, in case the age value is negative, we'll convert the age to 0. I'll give a semicolon, and then I'll write end if. I'll give another semicolon, and I'll close the delimiter. Now let me run this. Okay, so we have created our trigger. Now let's insert a few values onto customers. So I'll write insert into customers values 101, which is the customer ID. I'll give the age as 27, and let's say the name of the customer is James. Let's insert another record, give the value as 102, and this time I'm purposely giving the age as -40, which is less than 0, so that you can see the output clearly. I've given the customer name as Amy. Let's insert two more records. The customer ID with 103 has an age of 32, and let's say the name is Ben. I'll give another comma, and finally we'll insert our fourth customer record. The customer ID is 104. The age I'm giving as -39, which is less than 0 again, and let's say the customer name is Angela. Alright, now let me run this. Okay, so we have successfully inserted 4 rows of information to our customers table. Now let's see the difference. Since we had created a age verify trigger which would change the values of the age column in case the age value is less than 0. So now that we have inserted 4 records to a customer, so let's see what we have in the customers table. Now let me run it. There you go. So if you see this, for those customers where the age was less than 0, such as 102 and 103, you can see here our trigger has automatically converted those values to 0. If you can see the trigger we had created, we had set our new age to 0 if the age was less than 0, and this is the output we get. So here we looked at how a before insert trigger works. Alright, now moving ahead, let's understand how an after insert trigger works. So I'll give a comment here as after insert trigger. Now in this example, we'll create two tables, customers and message. Now the trigger will be fired if the birthday column has a null value in the customers table. You will get a message to update your date of birth. Okay, so first let me create my customers table. Now since we already have one customers table, I'll name it as customers 1, and let me give the column names. So the first column would be the ID column. This is going to be an integer, and I'll use the auto increment parameter, and this will be my primary key as well. Next we'll have the name of the customer. This is going to be of type varchar, and I'll use not null constraint. Next we'll have the email ID of the customer. This is again going to be of varchar type, and the column we are interested in is the birthday column. So I'll write birth date. This is going to be of type date. Okay, so let's create our table. Alright, now we'll create our second table, which is going to be message. Let's create the columns. This will have ID, int, and I'll use the auto increment operator. Next we'll have the message ID. This is going to be of integer type. We'll have a column called message. This will be of varchar type, let's say 300 characters, and not null. And I'm going to set my primary keys as ID and message ID. Let's create our second table then. So we have some error here. Let's debug the error. Okay, so I forgot to close the bracket here. Alright, now let me run this table. Alright, so we have created our message table as well. Next, I'll write my after insert trigger command. So I'll write delimiter. Next, I'll use create trigger command. So I'll write create trigger. My trigger name would be check underscore null underscore date of birth. After insert on customers 1 for each row begin if new dot birth date is null, then we are going to insert into our message table. We'll give the columns as message ID and message values new.id, comma, I'm going to use the concat function where I'll give my message, let's say hi, followed by the name, followed by, let's say, please update your date of birth. Okay, now I'll write end if. I'll close the delimiter. Okay, so let me go to the top and recheck if we have created our trigger correctly. So I have my trigger name after insert on customers 1 for each row begin if our new birthday has a null value, then we'll pass in a message saying hi, the name of the customer, then the message would be please update your date of birth. Alright, so let's run the trigger. Okay, now the next step is to insert a few records to customer table. So my name of the table is customers 1. Okay, I'll give the column names as name, email and birth. Okay, we'll pass in a few values. So our first customer's name, let's say, is Nancy, comma, I'll give my email ID, let's say nancy@abc.com. Now let's say I'm purposely passing the date of birth as null. I'll give a comma. My next customer, let's say the name of the customer is Ronald, and then I'll give the email ID such as ronald@xyz.com, and this time I'm going to pass in the date of birth, let's say 1998 November, and let's say 16th. Okay, now we'll add another customer, let's say Krish. We'll give the email ID of Krish, so krish@xyz.com, and let's say we'll give the date of birth as 1997 08 20. And finally we'll add one more record for another customer, let's say Alice. I'll give the email ID as alice@abc.com, and this time I'll purposely pass the date of birth as null. Alright, so let's run the insert query. Okay, now let me display the message table for you so that you can see the output and how our after insert trigger works. There you go. So if you see this, we had inserted 4 rows of information, out of which the first customer ID and the fourth ID had null date of birth. So for those two values you have the message as "Hi Nancy, please update your date of birth," and then you have "Hi Alice, please update your date of birth." Now you can give a space between hi and the name of the customer. Alright, now moving ahead, let's understand how before update trigger works. So I'll give a comment here as before update. Okay, now to show you how before update works, first we'll create a table called employees. Alright, so let me create my table, that is create table employees. I'll give my column as employee ID. This is going to be an integer type and it will be my primary key. Next we'll have the employee name. This will be of varchar type, and let's say the size would be 25, comma, then we'll have the age of the employee. Age will be of integer type, and finally we'll have the salary of the employee. Salary will be of type float. Let's create this table. Alright, now the next step is to insert a few records to our employees table. Okay, so here on the notepad I have already written my insert query. So I have inserted nearly 7 records. So let me paste it here. Alright, I'll just go ahead and run this insert query so that we'll insert 7 employees to our table. Okay, next we'll write our before update trigger command. So first and foremost I'll write my delimiter followed by the create trigger command. I'll give my trigger name as update underscore trigger. Let's bring this to the top. Okay, I'll use before update on my table, that is employees. For each row I'll write begin. My condition would be if new dot salary is equal to, let's say, $10,000. I'll write then set new dot salary equal to $85,000. I'll give a semicolon. Then I'll use else if new dot salary is less than $10,000, then I'll set new dot salary to, let's say, $72,000. I'll give a semicolon. I'll end the if statement. I'll close the delimiter by giving a semicolon. Okay, so if you see the employees table, we have the salary values here. Now in case while updating the table, if the salary is equal to $10,000, we'll set the new salary to $85,000. Else, if the salary is less than $10,000, we'll set the salary column values to $72,000. So let's go ahead and run this trigger query. Alright. Now let me use my update command. So I'll write update employees. I'll write set salary is equal to, let's say, $8,000. Now if you see our trigger query, we are setting the salary to $8,000, which is clearly less than $10,000. So our new salary would be $72,000. So let me run this. Okay. So you can see here 6 rows affected. So I'll write now select star from employees. Let's run this. Okay. If you see this, we have converted our salary column to $72,000 since we updated the salary to $8,000, and according to our trigger query, if it's less than $10,000, the salary should be $72,000, which you can see here. Alright, now moving to our final demo. This time we are going to explore how before delete trigger command works. So in this example, we'll create a table called salary. We'll store the deleted record in a new table using the before delete trigger. So first, I'll give my comment as before trigger. Comments are always useful since they make your query more readable. So let me now create my salary table. So I'll write create table salary. I'll give my column names as EID, which is employee ID, and I'll set it as primary key, comma, I'll give another column, let's say valid from, which means the date from which this salary was effective. This is going to be of type date and not null. And then I'll have the amount. Amount will be of type float, and again not null constraint. Let me run the create table command. Okay, so we have created our salary table now. The next thing is to insert a few values. So I'll write insert into salary. I'll give my column names as EID, comma, valid from, comma, amount. I'll write values. My first employee ID would be 101, followed by a date, let's say 2005, May, and 01, which is 1st of May 2005. Let's say the amount is $55,000. I'll give another row of information. This time the employee ID is 102, and I'll give a valid from date. Let's say the amount is 68,000. I'll give another employee ID, let's say 103, 2006, 0901, and let's say the amount is $75,000. Okay, let's run this. Alright, you can verify also. So I'll write select star from salary. You can see here we have inserted 3 rows of information. Alright, the next step is to create another table that will store the deleted rows. So I'll write create table. Let's say the name of the table is create or let's say salary delete. I'll write salary del. Now this will have the ID, the type would be integer, and primary key. I'll also use the auto increment operator. Next we have the EID, which is of type integer. I'll write valid from date and not null. Then I have the amount column, which is of type float and not null. My final column would be deleted at. The data type will be timestamp. I'll use the default constraint as now. So this will return the time and the date at which the record was deleted. Alright. Let me create this table. Okay. Finally, let me write my before delete trigger command. So I'll first declare my delimiter. Let's say this time I'm using the dollar symbol. I'll write create trigger. My trigger name would be salary underscore delete before delete on my table, that is salary. For each row I'll write begin. Next, let's insert into salary delete. I'll give my columns as employee ID, valid from, and amount. Now we'll insert a few values. I'll write values old dot eid comma old dot valid from comma old dot amount. I'm going to close with the delimiters. Alright, so let's run our before delete trigger. Alright, now let me go ahead and delete one of the records from the salary table. So I'll write delete from salary where employee ID is, let's say, 103. Let me run this query. Okay, so you have successfully deleted one of the records in the table. Now if you see our other table, that is salary delete, you will find this information present in the salary delete column. So we had deleted one row of information, that is for employee ID 103, which you can find it here. Now the final column, that is delete at, shows the time at which the information was deleted or the row was deleted. Alright, so let me go to the top and just give you a recap of what we did in this demo. So first we created a database called triggers. Then we started with before insert trigger, where we inserted customer table, and then we verified the age of the customers. So we saw if the age was less than 0, then we set the age to 0. We inserted a few records to the customers table, and purposely we inserted some negative age records, and then we converted this age records to 0. Then we learned how an after insert trigger works. So we created two tables, customers 1 and message. So wherever the customer's date of birth was missing, we passed in a message saying, hi, the name of the customer, please update your date of birth. Alright, Now moving ahead, we saw how before update trigger works, and finally we learnt about before delete trigger. So in this video we will learn subqueries in SQL. We'll also have a look at stored procedures and learn about triggers in SQL. We'll cover views in SQL and look at some of the important Windows functions in SQL. Now to learn all of these, we'll be using the MySQL workbench on Windows. So let's get started with subqueries in SQL. So let me head over to my MySQL workbench. So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright, so this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee from my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this, this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay. Now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay. So first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was $. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is SP_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is SP_sort by salary, the other 2 were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is SP_sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure we created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now, instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /. Then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name, I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore employees, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to /. I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we'll learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting. If any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay. Now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust_details. Then you write as select. I'm going to select a few column names from my original customer table which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright. I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust_details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there is some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name that is product_description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table. I'll give an alias as P followed by inner join my other table that is product lines as, let's say, PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay. So here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay. Now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cust details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright, now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay, I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright, now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name, 102. The name is Bradley. I'll give a comma. This time for 103 we have 2 records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the 5th student, which is Kevin, we have 2 records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table. that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley, but here if you see for Herath, the second record it says 2, which means there are 2 records for Herath, and if I scroll down there is 1 record for Nathan and there are 2 records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when 2 or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a, as an alias name, let's say test rank, from my table, that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function assigned the same value, which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function, which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column, that is salary descending. I'll give an alias as highest underscore salary from my table, that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table, Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function, that is first underscore value, followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table, that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter notebook and the MySQL workbench. You can see it here. So we will write our SQL queries in the Jupyter notebook with Python-like syntax. If you don't have MySQL or Jupyter notebook installed, so please go ahead and install them first. While installing the MySQL workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL workbench. So once you connect, it will ask for the username and the password. So I've given my username as root, and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import mysql.connector. Next, from mysql.connector, I'm going to import my error method or the error module. Next, I want to import Pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in 3 parameters. First is the host name, next is the user name, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is mysql.connector.connect. Now this mysql.connector.connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in 3 parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright, now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as err, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon, and I'll use curly braces, give err, and then I'll close the double quotes. After this, I'm going to return my connection. Alright, let me give a comment here. we are going to assign our password. So we need to put our MySQL terminal password. So this password you assign it while installing MySQL Workbench. I'll write PW and I'll give my password, which is simply @12345, and then I'm going to give my database name. So I'll give database name. Here I'm going to write DB equal to, this is the database I want to create, which is going to be MySQL_Python. Let me just scroll this down. Okay, now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give PW, which is my password, that is exactly simply @12345. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL_Python. So I'll give a comment, create MySQL_Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and except block. So I'll write try, give a colon, and here I'm going to use cursor dot execute. Within that I'm going to pass in my query. Next I'll use a print statement, and the message I'm going to display is database created successfully. After this I'm going to write my except block. I'll write except error as err, give a colon, and then I'll use a print statement. I'll write print, I'll use the formatting again, error colon, and I'll write within single quotes, I'll give curly braces err, and then I'll close the double quotes. Next let's use the variable create underscore database underscore query, and here I'm going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be mysql_python. Okay. After this, I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create_database_query. Let me just copy it, and I'm going to paste it here. Alright, so what I am doing here is I am creating a new function, that is to create a new database with the name mysql_python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and except blocks. So this try block statements will try to create my new database, which is mysql_python. In case it fails to create the new database, the except block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL workbench or the MySQL shell. You can see on the MySQL workbench here on the left panel under schemas, there is a database called mysql_python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. Now, so let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create_db, which is for database_connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line, I'm going to create my variable, which is connection, and then I'll assign it to a value none. After this, I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write mysql.connector.connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host_name. I'll give a comma. Next it will take the username, so user equal to user_name. Give another comma. Next it will take the user password. I'll use passwd equal to user_password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db_name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as err, give a colon, and then I'll use the print statement. F within double quotes I'll write error colon, within single quotes curly braces I'll write err, and will close the double quotes. Finally, this function will return the connection value. Alright, let's run it, and there you go. It has run successfully, so we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright. Now to execute our SQL queries, I'll use another user-defined function, which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next, we'll use the try and except block, so I'll write try cursor dot execute. This will take in one parameter, which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print. Let's say the message would be query was successful. And then we'll write our except block, which is except. If the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write err and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, now it's time for us to create our first table inside the mysql_python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names. The first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. We'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is mysql underscore python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here my SQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL workbench. So let me show you how to do it. So I am on my MySQL workbench, and under MySQL underscore Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price, and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. Let's say the variable name is data underscore orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into my table name, that is orders, followed by values, and now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. Let's say it is 2018. I'll choose 06 as the month and the date is, let's say, 12. I'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random. Let's say 62937330. Let's say 802. Alright. Similarly, I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay, let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. We have Steve, George, Stacy, Nancy, Maria and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create underscore db underscore connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data underscore orders. So this will store my insert into command. You can see the variable I have used here is data underscore orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here my SQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read underscore query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection.cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in 1 parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as err, give a colon, and I'll use my print statement. Just scroll this down. I'll use my formatting f error, give a colon followed by a space, within single quotes inside curly braces I'll give err and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause, having, whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table. So the way to do is, I'll assign my query to a variable, let's say Q1. I'll give triple quotes. Within triple quotes, I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line, which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is Q1 for the query. Next, to display, I'm going to use a for loop. I'll write for results for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable Q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of Q1 we'll put Q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have their respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that, I am going to use the year function. I'll edit this query. Instead of Q1 I'll make it Q3, and here I am going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to Q3. Q1, Q2, Q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here in Q3 I'll write Q4. I'll make this as Q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our 5th query, and this time we are going to explore how you can use the where clause. So I'll change this to Q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next I'll write where my date underscore ordered is less than, within quotes I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line. So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write a 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next. Now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list and then I'm going to append it to the empty variable or the empty list, which is from underscore db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now that will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name. Then I have the date on which it was ordered. Give a comma. Then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column. And finally, we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from underscore db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame, which is df. Alright, so here I am creating a empty list first, and then I am creating a for loop, and I am appending the results to my empty list. Here you can see I have created my column list, and using pd.dataframe I am converting the list into a data frame. If I run this is append and not appends. Alright, you can see we have our data frame ready. This is the index column, it starts from 0 onwards, and then we have the different column names. Okay, now let's see how to use the update command. Now suppose you want to change the unit price of one of the orders, you can use the update command. So the way to do it, I'll first create my variable, let's say update, and I'll give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit underscore price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say, $45. I want to update this particular record, so I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders, where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50, now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause, where let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer name Maria, and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete underscore order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this. We'll paste it here. I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, so this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported Pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL_Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read_query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was year. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command.
In this session, we will learn who is a SQL developer and what are the responsibilities in a company. Then we will focus on the skills required to become a successful SQL developer. We will see the expected average salary in both US and India. We will also discuss how to become a SQL developer and look at the top companies hiring for SQL developers. So hey everyone, I'm Abhisar Ahuja from Simplilearn and welcome to this video on how to become a SQL developer. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. When going through some of the popular job boards online, you would easily see SQL developer is one of the most demanding jobs sought by companies. As we all know today, companies collect vast volumes of data and store it in their own databases. They want professionals with a good understanding of data who can keep it safe and secure. So, first we will understand who is a SQL developer. SQL developer is a person who is accountable in creating and managing huge data assets of a company. In other terms, SQL developer is a person who can develop SQL databases as well as write and test code. Let's understand this with the help of an example. Let's say we want to search a particular product on Amazon website, and Amazon has stored all its data about products in a database. Now we will write the product name in the search bar, and when we click on the search button, it will run a SQL query that fetches all the information about the product and displays us on the website. So this is the basic task done by a SQL developer. Now we will understand the responsibilities of a SQL developer. All databases have a structure and logic behind how data is stored and retrieved. A SQL developer designs the database accordingly for businesses, that is called database modeling. After the database is created and deployed, it's the SQL developer who is responsible for fixing the general issues of the database. SQL developer should be well versed with structured query language to create optimized SQL queries and refines the existing ones to extract information from the database. SQL developers run several diagnostic tests to keep a check on the server and the database. In order to understand how to organize companies' data, SQL developers must communicate with technical and non-technical persons from the business, and SQL developer also gathers client requirements and identifies the features that the database owners want. As data is an asset to a company, SQL developers backup and restore data for their clients. They also perform tasks like data management and data migration. That is, if a company has stored all its data on a local storage and now it wants its data to be stored in a cloud storage. So the safe transmission of the data from local storage to cloud storage is known as data migration, and that is done by the SQL developers. After knowing the responsibilities, now we should look for skill set required to be a good SQL developer. One should have a good knowledge of SQL commands, functions, joins and procedures. Let's have a look at few commands such as create, drop, alter and truncate. These commands come under data definition language. We also have insert, update and delete commands. These commands come under data manipulation language. We have grant and revoke commands. These commands come under data control language. We also have commit, rollback and save point commands. These come under transaction control language. These are the basic commands a SQL developer should be familiar with. And a SQL developer may have a little command on any one programming language. You don't have to be expert in programming. All you need is how to interface between application and your database. For example, you are using MySQL and your web application is based on PHP. Then you should know how to connect your application to the database and how to issue queries, how to fetch results and then how to display it to the users. One should have a good understanding of various database management systems such as MySQL, Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, SQLite, IBM DB2, LibreOffice Base, MariaDB, and Microsoft SQL Server. One should know integration of databases with data visualization software such as Power BI and Tableau, which helps businesses to make better decisions and give you an add-on as a SQL developer. One should develop critical thinking and problem-solving skills to create optimized queries. Now we'll see how a SQL developer is compensated in both United States and India. In the United States, SQL developers draw an average salary of $72,282 per annum. In India, the average salary of a SQL developer is Rs 4,49,532. Now we'll see how a person can become a good SQL developer. For that, one should have a good command on structured query language and know how to interact with database management system and can issue queries to get the desired result. Earning industry recognized SQL developer certifications such as Microsoft Certified Professional Developer MCPD or Oracle PL SQL Developer Certified Associate, which usually require a passing score on an exam. And it's important to accumulate as much practical experience as possible. Start by designing, creating, and querying small databases connected with your hobbies and interests. For example, your favorite music, videos, or your personal finances. This will enable you to gain experience, test your knowledge, and build your project portfolio, which will be highly beneficial when you start applying for your first full-time position. Now we will see some major companies recruiting SQL developers. First we have the multinational financial services corporation American Express, followed by the multinational professional services network Ernst & Young. We also have the messaging company WhatsApp. Then we have the e-commerce giant Amazon, as well as the technology and computer solutions company Dell. Finally, in our list of companies, we have the multinational technology company Google.
SQL is a very important technology that is used in the IT industry. Professionals working as application developers, web developers, data analysts, data scientists, software testers, and cybersecurity experts need to know SQL. In this video, we will cover 30 important SQL questions that are most frequently asked in the interviews. Now, these questions consist of a set of theoretical and practical questions. So we will use different commands, functions, joins, and other functionalities in Excel to solve the problems. So let's get started with the first question. So the first question is to state the difference between where and having clause in SQL. Now, where and having are very widely used in SQL to solve specific problems. Now let's look at the difference one by one. So where clause is used to filter the records from the table based on the specified condition and can be used without the group by clause. On the other hand, having clause is used to filter the records from groups based on specified conditions. Now where clauses cannot have aggregate functions, so you cannot use sum, count, average, min and maximum functions in the where clause. While in the having clause, you can operate on aggregate functions, and those aggregate functions are used to filter values from a group. Now where clause is implemented on rows or at row level. So for each row of data, you have the where condition applied. Now having clauses are implemented on columns. So for each column of data, you have the having condition applied. Now another important difference between where and having is that the where clause is executed before the execution of the group by clause and after the execution of the from clause. On the other hand, the having clause is executed after groups are created. Now we will learn more about where and having and understand the usage better when we tackle practical problems in this video. Now moving to our next question, which is how is drop different from truncate? So drop and truncate are two different commands. So drop command is used to drop the whole table, removing the table definition and its contents, while truncate deletes all the rows from the table. Now we can drop the whole table structure in one go, so the view of the table does not exist. By using the truncate command, the existence of all the rows in the table is lost, but the view in the table exists. Now integrity constraints will be removed in drop command, while the integrity constraints will not be removed when you use the truncate command. Now moving to our third question. Now this is a practical question. So we will be using a table which is present in my MySQL database. So the table name is called employees, and I want to find the lowest salary of the employees in each department. You can see here, this is how my employees table looks, and the output query would be something like this. So here, since I want to find the lowest salary of the employees, so I'm using a min function to find the lowest salary in the table, and then I'm grouping all the employees and the results by department. So let's do this on MySQL workbench. Okay, so here I am on my MySQL workbench. First, let me go ahead and create a new SQL script. So I'll click on this, and that will create a new script. Okay, so here we'll write our commands. Alright, so our question was to find the lowest salary for each department. Okay, so I've given my comment to make my commands and whatever I'm doing more readable. So first, before I proceed, I need to select my database. So I'm going to use my SQL_intro database. So I'll write use SQL_intro. Now this database has a lot of tables that we'll be using in this interview questions video. I'll run it. Okay, we are in our SQL intro database. Now there is a table called employees. Let me show you the table first. If I write select star from employees, okay, so here you can see this is the table I'm talking about. Now these are the rows that are present in the table. We have 20 rows, and here you can see the different columns. We have the employee ID, employee name, age, gender. We have the department, city and salary. Now this is the same table that we have also used in our other videos that are already live on YouTube. Okay, so let's solve our question to find the lowest salary for each department. Now for that, I'll write select. I'll select my department column, which is DEPT, comma, and then to calculate the lowest salary or to find the lowest salary, I'm going to use the min function. So that will return the minimum salary present in the salary column. So I'll write min salary as I'm giving an alias name as, let's say, lowest underscore salary from my table name, that is employees. Then I'll write group by department. Now I'm grouping it by department because we want to find the lowest salary of the employees in each department. Now let's run and see the result. There you go. I'll just move it to the top so that you can see the results clearly. Okay, so here we have total 7 departments, you can see at the bottom, and in these 7 departments you can see in sales 70,000, let's say, dollars was the lowest salary. In marketing we had $55,000 as the lowest salary. Similarly, if I scroll down, we have other departments like tech, IT, finance and HR. So these are the lowest salary in each department. Alright, now moving to our next question. So our fourth question is, which query will help you fetch unique values from a column in a table? So this is a multiple choice question, which is another type of question that is often asked in the SQL interviews. Now we have multiple queries here and you need to choose the right query that will solve our problem. So since I want to get the unique values from a column in a table, so the right option would be to use the distinct keyword in the query. So if I write select distinct followed by the column name, let's say you want to find the distinct cities or the distinct departments in the employees table, so the query would be select distinct city or let's say department from the table name, that is employees. Hence this is the right option if you want to find any unique values from a column. Now moving to the fifth question. Now the fifth question says, it is actually a similar question here. We want to write the SQL query to fetch unique departments from the employees table. So as we saw, this is our employees table, and if you want to find the unique departments from the employees table, you can just write select distinct then followed by the column name, which is departments here, so DEPT from employees. Let's do this on our MySQL workbench. Okay, so let me just scroll down and I'll give a comment here, that is we want to find the unique departments. So the query would be select, then I'll use the distinct keyword. If I hit tab, it will autocomplete. Then I have my column, that is department, from my table name, that is employees. If I run this, the query will give us the unique departments that are present in the table. So here we have total 7 unique departments in the table. You can see here we have sales, marketing, product, tech, IT, finance and HR. But if you see our original table, which is the employees table, so there are total 20 records, and if you see the department column, there are multiple departments to which each of these employees belong to. Okay, now moving ahead. Now the sixth question is to write an SQL query to fetch the unique values of departments and print their length. Now this question consists of two parts. First, we need to fetch the unique values of departments that we saw in our fifth question, and then we want to print the length of each of the departments. So for that, I'm using the distinct keyword to find the unique departments, and then I'm using the inbuilt length function that is present in MySQL to find the length of the department, and then I'm using an alias that is length underscore department from employees. So let's say this on our workbench. Okay, so let me give a comment. I'll say unique departments and length. Okay, so the query would be, I'll write select distinct department, and then let me just scroll down. I'll give a comma and use my inbuilt length function. See, I'm hitting tab to autocomplete, and inside the length function I'll give my column name, that is department. I'll give an alias as department underscore length from my table, that is employees. This is pretty simple. So first I am finding the unique departments, and then using the length function I am finding the length of each department. Let's run and see. Okay, you can see the result here. So sales, the length is 5. Marketing, the length of marketing is 9. So basically you are counting the number of characters that are present in each of the departments. So in sales there are total 5 characters, in marketing there are total 9 characters, in product there are total 7 characters, in IT we have just 2 letters I and T, so hence the length is 2. Similarly finance is 7 and HR is 2 because we have just 2 letters H and R. Okay, so this is another variation of using distinct along with any inbuilt function. Alright. Now moving to the 7th question. The question is, what is the use of dateDiff function in SQL? Now dateDiff returns the number of days between two date or date time or timestamp values. So dateDiff is another crucial inbuilt function that is present in MySQL. So here is how you can use the dateDiff function. So it will return the number of days between two dates or date time or timestamp values. So here I have two date values, that is 10th of April 2021 and I have 30th of March 2021. So this query will give us the total number of days that lie between these two dates. And similarly, here is another example of using the dateDiff function. So I want to calculate the total number of days that are present between today's date, so I am using the now function, and between 20th of April 2021. So let's do this demo on the workbench. Alright, first I'll give a comment saying dateDiff function. Okay, now the way to use is I'll write select, and then you can see here once I type date, MySQL workbench is automatically suggesting some of the inbuilt functions. I'm going to use dateDiff, and within dateDiff I'm going to pass in two values. So I'm passing in two date values, let's say 2021 April, so I'll write 04 and let's say 10th of April. I'll give another comma and I'll pass in my second date value, that is going to be 30th of March 2021. Alright, now another thing to note here is the date value should be present inside quotations. Now if you want, you can give an alias as well. I'll write as total days. Let's run it. There you go. It has given us the output as 10. So there are total 10 days between 31st of March to 10th of April. Now let's see another example. I'll write select dateDiff and we'll pass in my now function. So the now function returns the current date, that is today's date, and I'll give another date value, let's say 2021 April 20th. Now we'll see the results. If you want, you can give an alias name so that the output is more readable here. I'll run it. Okay, so between today's date and my previous date, that was 20th of April, there are total 49 days. So today's date is actually 8th of June. So between 20th of April and 8th of June, there are total 49 days. Alright, now moving ahead. Now in the 8th question, we want to write an SQL query to display the departments that have more than 2 employees. So this is our employees table that we have been using, and here is how the command looks like. So here we are using both group by and having. Now I am grouping by department because I want to display the departments that have more than 2 employees. Now for the second filter, I am using the count function of the employee IDs and checking if the employees in each department are more than 2 or not. Let's do this. Let me move down a bit and I'll give a comment: departments with more than 2 employees. Okay, now let's write our query. So I want to select the department and then I'm using the count function to count the employee IDs in each department, or the employees present in each department. From my table, that is employees, I'm going to group by department, and then I'll use having my count of employee ID. This should be greater than 2. So our query will return only those departments which have more than 2 employees. Let's run and see. There you go. So we have total 4 departments, that is sales, product, tech and IT, where we have more than 2 employees. You can see here sales has 4 employees, product has 3, tech has 4 and IT has 3. The rest other departments like finance, HR and others have less than 2 employees. Now if you want, you can give an alias as well. Let's say as total employees. Okay, let me run it again, and here you can see I have the column name as total employees. Okay, so moving ahead, the 9th question, we want to display the details of the employees for all the departments except marketing. Now here I have my employees table. Now if I were to display all the details of the employees apart from marketing department, I can give a condition like where department not equal to marketing. So this is the way how you write not equal to. So you use the less than and greater than symbol. Another way to do is use the exclamation mark and give equal to. So this means select all the employees where department is not equal to marketing. Now let's do this. I'll move down a bit and will give a comment as details of employees apart from marketing. So the query would be select star from employees. I'm using star because I want to display all the details. That means I want to display all the columns. Then I'm going to use my where condition where department not equal to marketing. I'll put marketing under quotes. Let's run it and see the results. There you go. So we have total 18 rows of information, and if you see the department column, we have all the departments apart from marketing. Now if you remember, our employees table had total 20 rows of information, out of which 2 are missing, which means there were 2 employees who were from marketing department and those departments were not displaying. Now another way to do is to use exclamation mark and equal to. So this also means select all the employees where department is not equal to marketing. Let's run this. You see here it gives us the same result and has returned us 18 rows of information, leaving apart the employees from the marketing department. Alright, now moving ahead. So our 10th question is to write an SQL query to print the details of the employees who have joined before April 2010 and after May 2005. So here is my employees table and this is my SQL query. So here we are using just a where condition to filter our results, and my condition is the employee should have joined after May 2005. So I have written after 31st of May 2005 and before April 2010, which is before 31st of March 2010. Let's do this. I'll give a comment here. We'll write employees joined before April 2010 and after May 2005. Now let's write our SQL query. So I'll write select star from employees where my date of join. If you see here, I have a column called date of join, which has the details about the day on which the employee had joined the company. So I'm going to write where date of join is greater than 31st of May 2005. So I'll write 2005. This is one of the formats to use date values. So this is the year value, this is the month value, and this is the day value. And my date of join should be less than 31st of March 2010. So I'll write 2010 March 31st. I hope you were able to understand this. Date of join greater than 31st of May 2005 means after May 2005, and date of join less than 31st of March 2010. This means employees joined before 2010 April. Let's run it. Okay, so we have total 3 employees in our table. You can see the date of join, and all of them have joined after May 2005 and before April 2010. Okay. Now moving ahead to the 11th question. So here we want to find the employee with the third highest salary from the table. So I have my employees table here, and my command would look something like this. So here we are going to explore how to write subqueries in SQL. So I'm using a subquery here where I'm trying to find the employees who have the top 3 salaries, or the top 3 employees who have the highest salaries, and from that I'm going to filter out my third highest salary employee. So let's do it on our workbench. Okay, so I'll come down and let me give a comment as third highest salary. Okay, so let me first write down my SQL query and then I'll explain. So I'll write select star from. After that I'll start a bracket and write my inner query. So I'll write select star from employees order by salary descending. Then I'll use my limit keyword and I'll write limit 3 as I'll give an alias name, let's say T, and then I'm again going to use my order by salary limit 1. Okay, now let me explain you the flow. So first let me run the inner query. I'll select my inner query and I'll run it. So the inner query returns my top 3 employees who have the highest salary, and this is ordered in descending order since I used salary descending. Now let me just use this. Okay, now you can see it clearly. So these are my top 3 employees who have the highest salary. So Joseph has the maximum salary, followed by Angela, and then we have Jack. Now from this I want to return only the record for Jack, because Jack is the employee who earns the 3rd highest salary. So for that I am going to use the result returned by my subquery or the inner query, and on top of this I'm going to order the salary and say limit equal to 1. So I'm again ordering this salary in ascending order. So what will happen? Jack will appear at the top, Angela will be at the 2nd place, and Joseph will come to the 3rd place. And from there I'm using limit 1 so that I can only get the record for Jack. Now if I run the entire query, you see the result. I have my employee name as Jack, who earns the 3rd highest salary. Okay. Now moving ahead to the 12th question. The question is to print all the alternate records in a table. So here is my employees table, and from this table I am going to print all the alternate records. For example, I am going to print my employee ID 101, then I am going to skip 102 and print 103, followed by 105, 107, 109. So all the employee IDs that have an odd value. And you can look at this example in another way of displaying the employees which have an employee ID of even numbers. So 102, 104, 106 and so on. Now the way to do is, either you can use a simple select clause and say employee ID percentage or modulus 2 equal to 0, which means I want to filter only those employees which have an even employee ID. Else what you can do is you can use a CTE, as you can see here. So CTE, or the common table expression, is a temporary named result set that you can reference within a select, insert, update or delete statement. Now it is used to simplify complex joins and subqueries and to provide a means to query hierarchical data. Now let's write this query on our workbench and see how it works. But before that, let me explain you. I am using a few new functions such as row number. This will create a row number for each of the rows or the records present in my table. And then from this CTE I am going to use my filter clause or the where clause, where rn, which is row number, percentage 2 equal to 1. So this will return only the odd records from the table. Let's see how to do it. Okay, so I'll give a comment, print alternate records. Okay, now I'll start with my simple query, which is select star from employees, where let's say I want to find only the even employee IDs or the employees who have an even employee ID. So I can use employee ID percentage 2 equal to 0. So it has to be a perfect division and the result should be 0. Only then I can get only the even employees. If I run this, okay, there was an error here. It should be employees. I'll run it again. You can see here I have printed the alternate records in a table. So we have skipped 101 because it is not divisible by 2. I've started with 102, followed by 104, 106, 108, and then finally we have 120 or 120. Now if you want to print only the odd records in the table, you can use employee ID percentage 2 equal to 1. So you can see here I have 101, 103, 105, 107 up to 119. Now the best way to do this is to use a common table expression or CTE. So I'll start with my command, that is with CTE, as I'll start with my bracket. I'll write select star comma, then I'm going to use my row number function. So I'll write row number, then I'll write over, then I'll use order by employee ID. So this row number for each of the rows is going to be created over my employee ID column, and that is sorted in ascending order. I'll give an alias as RN, which stands for row number, from my table, that is employees. I'll scroll down, and then I'm going to close my bracket. I'll write select. Let me remove the space here. Okay, I'll write select star from CTE, where my row number %2 equal to 1. Now let's see this from the top. So I have my common table expression where I am going to create a row number column named as RN, and this row number column is based on my employee ID column, which is sorted in ascending order, and from that I'm going to filter only those row number values that are not divisible by 2, or I'm going to print only the odd records from the table. So let's run it and see the results. There you go. So here if you mark, I have my row number column created, and I am filtering only the odd records in the table. So it starts with 1, 3, 5, 7 and goes up to 19. And similarly here you can see the employee IDs, the name, the age, gender and other information. Now if you were to print the even records in the table, the alternate even records, you can use RN %2 equal to 0. Let's see the difference. I'll run this. There you go. So I have my even row number starting from 2, which goes up to 20. Okay, so this is how you can print alternate records in a table. Now moving to the next question. Now in the 13th question, we want to write an SQL query to fetch all the duplicate rows in a table. Now this is another crucial interview question that is often asked in most of the interviews. Now I have a table which is named as duplicate table, and here you can see I have some employee ID, name and age, and a few records are duplicated. For example, 101 Sam 40, the first record is duplicated, and you can see here it has the same values. Now if you mark 103 Mary and 28 is not duplicated because here the age is different, so this is a different person than compared to the third name that we have. So this is how you can find the duplicate rows in a table. So I'm going to select my employee ID, name and age, and then count all the employee IDs, the names and age, and compare them with whether they are greater than 1 or not. So if they are greater than 1, then I'll say that particular record is duplicated or is present more than one time in the table. Let's do this implementation on our workbench. Okay, so I'll come down and let me give my comment as duplicate records. Okay, so let me first show you the records that are present in my table. So I'll write select star from DUP underscore employees. I'll run it. Okay, you can see here I have my table that we saw in the slides. So employee ID 101 with name Sam and age 40 is duplicated. So we want to find this duplicate record. The way to do is I'll write select E underscore ID, which is employee ID, comma name, comma age, comma I'm going to count all of them. So I'll write count star, as duplicate count, this is my alias name, from my table, that is dup underscore employees. I'll say group by employee ID, name and age, and then I'm going to use my having clause saying having count of employee ID is greater than 1 and count of name should also be greater than 1 and my count of age should also be greater than 1. Let's run it and see the results. Okay, there is some error here. The name of the table should be employees. Okay, let's run again. We have our correct result, that is employee ID 101 with name Sam and age 40 is duplicated, so the value is 2. Great. Now moving ahead. Now the 14th question is a bit tricky, wherein we want to display the employees with exactly 2 A's in their name. So you see here I have my employee names and there are certain employees who have just 2 A's in their names. So I want to find those employees only. Now the way to do is, it is a bit tricky to understand. I'm going to break it down and make you understand on my MySQL workbench. So here you can just have a glance. I write select star from employees where I am finding the length of my employee name and then subtracting my length wherein I have replaced my employee name that has A with a blank, and if this subtraction is equal to 2, then that particular employee has 2 A's in their names. So let me show this first. Let me first give my comment as employees with 2 A's. Okay. So first I'm going to write a select statement. Okay, before that I'll show you the records present in my table. Okay, if you see here, Shane is one of the employees that has just 1 A in its name. Then we have Mary 1 A, Dwayne has 1 A, but if you see Sarah has 2 A in the name, so we want to extract Sarah. Then Jack has 1 A. Again, if you see Angela has 2 A. It doesn't matter if it is uppercase A or lowercase a, we just need to find if the employees have 2 A's in their name. And similarly, if I scroll down, let me check if we have any other employee with 2 A's in their name. Marcus has 1, David has 1, Sophia has 1. We also have Amelia that has 2 A's in its name or in her name. And we also have Maya. Okay, now let me go ahead and write a SQL query and then I'll explain you what I'm trying to do. I'll write select. I'm using the length function, and in the length function I'm going to replace, then I'll use another function called upper on top of employee name. I'll write A and then replace it with a blank. So I'm using quotations to represent blank from employees. Okay, let's run this and see the results. You see here it has given us the length of the employee strings after replacing all the A's with a blank. So here I'm essentially converting my employee names to uppercase and I'm changing wherever there is an A, I'm replacing that A with a blank, and then I'm finding the length. So this trick I'm going to use in my final query. So I'll write select star from employees, where what I'm going to do is I'll bring this to the next line. I'll write length of employee name minus, then I'm going to use my above condition. I'll copy this, I'll paste it here, and this value should be 2. So what I'm doing is I am first finding out the length of my employee name. From that I'm subtracting the length after replacing the A's present in the employee name with a blank, and this value should be equal to 2. The reason being, we are only trying to find the employees who have 2 A's in their name. Let's run and see the results. Okay, if you see here, we have Sarah, Angela, Emilia and Maya who have 2 A's in their name. So we have Sarah that has 2A, Angela has 2A, Emilia has 2 A's, and then Maya also has 2A. Okay, now moving ahead. Now the 15th question is, given a string, how will you extract 4 characters starting from the second position? So I have my string here which says Michael Ballack. Now Michael Ballack, you must be aware, is a popular footballer. He is from Germany and also was the captain of Germany. So from the string Michael Ballack, I am going to extract 4 characters starting from the second position. You can use 2 inbuilt MySQL functions to do this. The first is called substr, wherein we pass in the string, then we give the position from where we want to extract the characters. So here I am going to extract from the second position, so hence 2, and then the number of characters that you want to extract, which is 4. The other way is to use the substring function, which is again similar to the substr function. In the substring function also, I am first passing in my input string and then giving my starting position, which is 2, and then I want to extract 4 characters from it. Let's do it. I'll give a comment, extract strings. So here I'm going to write select. First I'm going to use substr, which is my inbuilt function. I'm going to pass in my input string which says Michael Ballack, and then I'll give my starting position, which is 2, and then the number of characters, that is 4. Let's run it and see the results. You can see here it has given us ICHA. So if you see, M is at the first position. From the second position onwards, I needed 4 characters, so M, C, H and A. These are the 4 characters starting from the second position. Similarly, let me just copy this, and instead of substr, I'm going to use the substring function. I'll write just ing, that becomes substring. Let's select and run it, and this also returns the same result. Suppose you wanted to extract from the 4th position, you wanted to extract, let's say, 3 characters. Let's see the results. It gives us H, A and E. If you see here, M is the first position, I is at the second position, C is at the third position, H starts from the 4th position. So H, A and E are the next 3 characters starting from the 4th position. So hence this is the result. Alright, now moving ahead. Now my 16th question is on how does self-join work. So self-join joins a table to itself. So the table must contain a column X that acts as the primary key, and a different column, let's say Y, that stores values that can be matched up with the values in column X. Now this might not be really easy to understand. You'll get to know once we do this demo. So I have a table which is called employee manager. So this is my table. Now let me tell you how to interpret this table. we have 5 different employees starting from employee ID 1 to employee ID 5. Gary, Gibbs, Smith, Latham and Jimmy are the different employees we have. You have their salaries, and now you have the employees reporting to which manager. Now if you see here, Gary's manager ID is 3. So if you see our table, at 3 we have Smith. So Gary is reporting to 3, or in other words, Smith has a employee under him who is Gary. Similarly, Gibbs is reporting to manager ID 1 or employee ID 1, which is Gary. So Gibbs manager is Gary. Similarly, if you see for Smith, Smith is reporting to the person with manager ID 4 or employee ID 4. We have Latham. So Latham has one employee under him who is Smith. Now Latham in our table has no managers. Then we have Jimmy who's reporting to the employee ID 3 who is Smith. Okay. Now I want to use this table and return the name of the manager for each employee. To do that, I am going to use my self join. So here I am using a self join to join both the tables. Here both the tables mean I am using the same table twice. So I have written select e.employee e.employee name, then we have e.manager ID, then I am using another alias for managers, so m.employee name as manager underscore name from employee underscore manager as e. This join means self join employee underscore manager as m on e.manager ID equal to e.employee ID. So this is my common column, that is employee ID and manager ID. Let's do it. Alright, I'll give a comment here saying self join, and I'll start with my self join. I'll write select. Let me first display my table. I'll write select star from, and my table name is emp underscore manager. I'll run it. You can see the table here. This is the same table that we saw in the slides. Now I'll write my join query. I'll write select e dot employee ID comma e dot employee name comma e dot manager ID comma, then I'm using another alias as m for finding the manager name. So m dot employee name as manager name. There shouldn't be any space in the alias name. Then I'll write from emp underscore manager as e join emp underscore manager as m on e dot manager underscore ID equal to m dot emp underscore ID. Let me run this and we'll see the results. There you go. So Gary reports to the manager ID 3. So from the table 3 is for Smith. So Gary's manager is Smith, Gibbs manager is Gary, Smith's manager is Latham, and Jimmy's manager is Smith. Okay, so this is how you can use self join. Now moving ahead with our next question. So the 17th question is on which of the following is called a virtual table in SQL. So again we have a multiple choice question. So the answer is view. You can see here. So view is a virtual table that has rows and columns as they are in a real table in the database. Now we can create a view by selecting fields from one or more tables present in the database. Next, moving to the 18th question. So here we want to write an SQL query to fetch the list of employees with the same salary. Again, I am going to use a self join here, wherein I'll join the same employees table, and this is how my query would look like. So I am selecting distinct employee ID, so e.employee ID, e.employee name, e.salary from employees. Then I'm joining employees as E on employees E1, where e.salary equal to e1.salary, because I want to fetch the list of employees with the same salary, and I'm ensuring that the employee IDs from both the tables are different. Let's do it. I'll give a comment here and write employees with same salary, and I'll start with my query. I'll write select distinct e dot employee ID, comma, I'll write e dot employee name, comma, e dot salary from employees as E, then employees as E1, where e dot salary equal to e1 dot salary and e dot employee ID is not equal to e1 dot employee ID. I'll give a semicolon and let's print the results. You see here we have Amelia, Bella, Shane and Sarah who have the same salary. So Amelia and Shane have the same salary of $55,000. Bella and Sarah have the same salary of $72,000. Okay. Now moving to the 19th question. So the question is to write an SQL query to print one row twice in results from a table. So I have a table here called employees and I want to print one row twice in the results. So to solve such kind of problems, you need to use the union all operator in SQL. So union all combines the result sets of two or more select statements. It does not remove duplicate rows. Between the various select statements, all the rows are returned. So let's say I want to print the employee name and department for those employees who are from the HR department. Now to do this, we can use the union all operator. You can see it here. So I'm selecting my employee name, the department from my table employees as E. Then I'm giving my where clause where e.department equal to HR, and then I'm using the union all operator. Then I'm again selecting my employee name, department from employees with another alias as E1, where E1 dot department equal to HR. So let's do this. Okay, so I'll give my comment as print row twice. Okay, now I'll start with my query. I'll write select my employee name, comma, the department from my table that is employees as E. Then I'll use where e dot department equal to HR. Then I'm going to use the union all operator. So the union all will combine the result set of two or more select statements. Then I'm going to write select emp underscore name, comma, my department from employees as E1, where E1 dot department equal to HR. I'll give a semicolon. Now let's run it. There you go. You can see here Marcus and Sophia are from the HR department and we have printed them twice in our results. Coming to the next question. The question is, using the num table, write a query to add 10 when number is 0, 20 when number is 1, else print the number itself. So you can see here I have my table called num, and it has just one column, which is num ID or number ID. We have some numbers here, and from these numbers I want to add 10 if the number is 0, 20 if the number is 1, else I would print the number itself. So to answer this question, we'll use the case statement in SQL. So the case statement is SQL's way of handling if-then logic. The case statement is followed by at least one pair of when and then statements. So here you can see I have my case statement. I'm writing when case, my column name n_id equal to 0, then add plus 10. If it is 1, then add plus 20, else we'll just return the number ID. Now let's do this. Okay, I'll give a comment saying using case statements. Okay, first of all, let me display the values present in my NUM table. You can see here this is my table and there are total 12 rows of numbers. Now let's start with our query. I'll write select n_id, comma, then I'm going to write my case statement. So I'll use the keyword as case when n_id equal to 0. I'll use then n_id plus 10. I'll write when n_id equal to 1, then n_id plus 20, else I'll just print NID. Now I'll end my case statement. I'll write end as an alias name, let's say num_add, from my table, that is num. Let's run and see the results. Okay, you can see here my first number was 0. So since it was 0, we have added numID or NID plus 10. So the result is 10. Now wherever the numID is 1, for example here we have added 20, so the result or the output becomes 21. Similarly here the value was 0, so we have added 10, the output is 10. And you see here again, here we had another 1, so we added 1 to 20, so the result becomes 21. And for the rest of the numbers, for example 3, we had 2, the values are the same. Okay, now moving ahead. So we have a table called num1, and using this table we want to write a query to find the sum of all positive values and the negative values. So let's see the table first. So this is my table, which is num1. You can see here we have a list of integers and there are positive as well as negative integers. So for positive values and the negative values, we want to find the sum separately. So again, for this we are using the case statement. You can see here I have used two case statements. I'm writing select and then I'm using the case to find if the number is greater than 0, which means it's a positive number. So I'm finding out the sum, and then I'm checking case when the integer is less than 0, so it's a negative number, and I'm finding the sum for the negative numbers as well. Let's do this. Okay, so I'll give my comment as add positive and negative numbers. Okay, so let's start with our select query. I'll write select. I'll use the sum function, and inside the sum function I'll use my case statement. So I'll write case when num underscore integer Okay, before that let me just print the values present in my table. So I'll write select star from my table name, that is num1. Okay, so you can see here these are the values or the list of integers that we have. There are some positive as well as negative integers. Okay, let's continue with our query. So here I'm going to write case when num underscore integer or int, which is my column name, if it is greater than 0, then I'll return num underscore int. Else I'll say 0 and end my case statement. I'll give an alias as sum of, let's say, positive numbers. I'll give a comma. Then I'll use another sum function, and inside the sum function we'll use the case statement to find the sum of negative numbers or integers. So I'll write num underscore int, if it is less than 0, then num underscore int, else 0, and I'll end. Okay, and I'll give another alias name as, let's say, sum underscore neg, which stands for negative. POS is for positive integers, and then I'll write from my table, that is num1. Let's run it. Okay, there you go. We have our results. So we have two columns, sum of positive integers and sum of negative integers. You can see the results, 19 and minus 14 respectively. Okay, now moving ahead. Now in question number 22, we want to list the difference between primary key and foreign key. So as you can see here, primary key is something that can uniquely identify a record in a table. So if you consider a school database, a primary key would ideally be the roll number or the registration number of the student, because that is unique to all the students in a school. Now foreign key is the field in the table that is primary key to another table. So suppose you have another table called courses to which the students have enrolled to. Now if you have a roll number or a registration number column in the course table, that becomes the foreign key. Now the other difference is primary key don't accept or cannot accept null values, while foreign key can accept null values. Now you can have only one primary key in a table, but you can have more than one foreign key in a table. Now coming to the 23rd question, what is the difference between primary key and union? So you can have only one primary key in a table, as we discussed in the previous question, but you can have more than one unique key in a table. A primary key column cannot have null values, but union can accept null values. Now if you assign a column as a primary key, you create a clustered index, and similarly if you assign a column with union, you create non-clustered index. Okay, now coming to the 24th question, what is a check constraint in SQL? So check constraints are used while creating tables. Check constraint helps to limit or restrict the values that can be inserted into a column. For example, we have a table here, let's say dummy1, and you want to ensure that every time you insert the age of people or persons in the table, you want to make sure that age should be always greater than 0. Reason being, a person cannot have, or an animal cannot have, or a tree cannot have a negative age. Similarly, you can set a constraint for the salary column in a table to ensure that it is always greater than 0, because you cannot earn a negative salary, or it cannot be less than 0. Now we are going to create a dummy table on my MySQL workbench and see how check constraints can be applied. Okay, so let's give our comment as check constraints. Alright, so I'm going to create a table called dummy, let's say underscore SQL. Now this table will have a few columns. First we have, let's say, EID, which stands for employee ID. The data type is integer, and I'm going to assign employee ID as my primary key. So I'll write primary key here. Okay, I'll give a comma. Next we'll have a city column. City column is of type var char or varying character. I'll give the size as 30, and here I'm going to apply my check constraint to this city column. I'm going to check the city should take only values as Mumbai. Let's say I'll have my final column, that is age. Age is of type integer, and here I'm going to check my age should always be greater than 0. So I'll write check age greater than 0. Okay, so our dummy SQL table has one primary key constraint, and we have applied two check constraints on city and age column. Let's run this. Okay, so we have created our table successfully. You can see it here. Now let's insert a few records and we can see the difference. I'll write insert into dummy underscore SQL. I'll write values. I'll have my employee ID as 101. I'm giving my city as Mumbai, which is what we want. And let's say I'll give my age as 10. Now this should perfectly work because my city is Mumbai and my age is greater than 0. So I should be able to insert this record successfully. You can see here I have inserted this record to the table. I'll write select star from dummy SQL so that you can check. Let's run it. There is some mistake. I should write from. Okay, let's run it. You can see it here. We have one record or one row returned. Now let's say we'll insert another record, and this time I'm going to give my employee ID as 102 because it has to be unique. And this time instead of Mumbai, I'm going to give my city as, let's say, Delhi. So I'm not following my check constraint where I am supposed to give only Mumbai. I'm purposely giving Delhi here to see the difference. If I run this, let's say we'll have age is 40, which is greater than 0. Let's run it. You see here we get an error saying check constraint dummy underscore SQL underscore check is violated. Similarly, let's say I'll change this to Mumbai again, and instead of 40, let's say I'll give us minus 30. So your age can never be in negative numbers. If I run this, I get the same error. My check constraint has been violated because age should be greater than 0. Okay, so this is how you can use check constraints in SQL. Now coming to the 25th question. So given two tables A and B, you want to write a query to fetch values in table B that are not present in table A. Now to answer this question, you can use the left join. So what left join does is it returns all the rows from the left table and only matching rows from the right table. And I've used my condition as a.id, which is in the right table, should be null. Let's write this query on the workbench. Okay, so I'll give my comment using left join. First of all, let me display my tables. I'll write select star from A. Where on this I have the IDs. There are total 5 IDs in table A. Similarly, I'll copy this and will see the values that are present in table B. So again, I have 5 values. There are a few non-matching values as well. So I want to return those non-matching values that are not present in table A. So for that, I'll write select ID from table B. I'll use left join A using my ID column. This is another way to give the condition, or you can use the on operator. Then I'll give where a.id is null. Let's run and see the results. There you go. So 150, 200 and 75 are not present in table A but are present in table B. Okay. Now moving ahead. So now we'll look at the last set of 5 questions. So these questions are based on the popular Northwind sample database provided by Microsoft. Now there are several tables in this database. So we have an order table, customers, employee, products, a region table and others. We'll use our Microsoft SQL Server to solve the 5 questions. So my next question, which is based on Microsoft SQL Server, the question is, using the Northwind database, find the customers who don't have any orders. Okay, so I am on my Microsoft SQL Server Management Studio. So this is how the interface looks like, and here you can see I have a list of databases. Now to solve the last 5 questions, I'm going to use the Northwind database. If I expand this, I'll click on the plus sign. You can see there are a lot of tables that are already present in the database. You can see here we have customers, employees, employee territories, order details, orders, products, region, shippers, suppliers, territories and more. Okay, let me just collapse this. Alright, so to write my queries, I'm going to create a new query file, and here you see I am currently on my master database. I'm going to change this to Northwind database so that we can utilize all the tables that are present. So my 26th question was to find the customers who don't have any orders. So for that, I'm going to use 2 tables, customers and orders. So let me first give a comment saying customers with no orders, and now let's go ahead and display the columns that we have and see the records present in the tables customers and orders. So first I'm checking all the columns and the rows present in the customers table. I'll execute using this button, or you can hit F5 as well. Okay, you can see here there are total 91 customers. These are all unique customers. You have total 91 unique customer IDs. You see here the company name of the customer. You have the contact name, the contact title, address, city to which the customers belong to, then the region, postal code, country, phone, fax number. Okay, now let me just copy this query, and now we'll check for the orders table. I'll write select star from orders, and let's execute it or run it. Okay, so there are total 830 rows of information. So there were total 830 orders or order IDs. We have the customer ID. Now this customer ID is actually the foreign key for the orders table. but for the customers table, customer ID is the primary key, and in the orders table, order ID is the primary key. We also have the employee ID. Again, this employee ID is the foreign key for this orders table. We have the order date, we have the required date, ship date, ship via, which means by which medium the order was shipped. We have the freight charges, ship name and ship address as well. Then you have the city from which the item was shipped, the region, postal code and the country. Okay, now let me use the distinct keyword. I'll write select distinct. I want to find the distinct customer IDs from my customers table. Let's run and see how many unique customer IDs we have. So there are total 91 customer IDs or customers. Now let's check for the orders table. Let's run it and see the difference now. If you see here, there are total 89 customer IDs in the orders table, which means there are 2 customers missing from the orders table, and that implies those 2 customers don't have any orders. So to get the result, I will use 2 different queries to derive at the same output. So I'm going to select my customer ID from my table, that is customers. I'm going to use where my customer ID, and then I'm going to use the not in operator. I'm going to use a subquery select customer ID from my orders table. Close the bracket and I'll give a semicolon. Now what this query essentially does is, it is first going to find all the customer IDs that are present in my orders table, and in the outer query we are only going to return the customers that are present in both the tables, and we are going to exclude those customers which are not present in the orders table. So let's run and see the results. We should get 2 customer IDs. There you go. So these are the 2 customer IDs which are present in the customers table and are not present in the orders table, meaning that they don't have any orders in their name. Now there is another way to do it, that is to use the not exists operator, wherein you can write another subquery to get the same result. We'll leave that to you. You can try this out using the not exists operator as well. Coming to the 27th question. Using the orders table in the Northwind database, we want to find all the month-end orders. So such problems you will face while dealing with sales data. So very often sales executives would try hard to meet their month-end targets. We want to display all the orders made on the last day of the month. So let's solve this question on our Microsoft SQL server. Okay, so let me first give my comment for the 27th question. So the question is to find all the month-end orders. So I'll just write month-end orders. Okay, now to get the month-end orders, we are going to use a built-in EO month function which stands for end of month. So let's start with the query. I'll write select. We are going to select the employee ID, comma, I also want the order ID, and we want the order date from my table, that is orders. I'll then give my where clause. I'll write where my order date equal to, and I'll use my inbuilt function, that is end of month. I have hit tab to autocomplete, and inside this function I'll pass in my order date column. Then I'm going to use the order by clause. I'm going to order it by employee ID and the order ID. I'll just move down and hit tab. Okay, let's run the query. There you go. We have got 26 rows of information. You see on the left side we have the employee IDs, the order IDs, and then we have the order date column. Now if you mark the values present in the order date column, these are all the end of month date values. You see this is 28th of Feb, then we have 31st of July, we have 30th of June, so on and so forth. So these are the list of all the orders that were placed on the last day of the month. Now coming to the 28th question, we want to find the top 5 countries with the highest freight charges in the year 1997. So freight charge is the amount paid to a carrier company for the transportation of goods from origin to another location. The freight charge is calculated based on the mode of transportation and the distance between the pickup place or the pickup location and the destination. So let's try this out on the Microsoft Server Management Studio. Okay, so let me go ahead and give my comment. So since we want to find the top 5 countries with the highest freight charges, I'll just give my comment as highest freight charges. Okay, now to solve this question, I'll just change this to GHT. Okay, we are going to use our orders table. So the way to do is I'll write select. I'm going to use the top 5. So top is another keyword or an operator. So I'm going to find out the ship country, and then I'll calculate the average freight prices. So I'm going to use the average inbuilt function on top of my column, that is freight. I'll give an alias as, let's say, average freight. There should be no space. I'll give a underscore. I'll write from my table, that is orders. I'll use my where clause where, and then I'm going to find the year from my order date column, and this year should be 1997. I'm going to group it by my ship country, and I'll use order by my alias name, that was average freight, and in descending order I'm going to sort it. Let's see the top 5 shipping countries who have the highest freight charges. These are the results. You have Austria, Switzerland, Sweden, Canada and Ireland, and here you can see the average freight prices sorted in descending order. Okay, now moving ahead to the 29th question. So here we want to display the total number of products in each category. So we have two different tables, products and categories. So both these tables we are going to use to find a solution to this problem, that is to display the total number of products in each category. So first let me give my comment to display the total number of products in each category. I'll just write print total products. Okay, so to solve this problem we are going to use our two tables. So let me first display the rows and columns from both the tables. The first table is products. Okay, it is products. Let's run this and see the columns that we have in this table. Okay, so you have the product ID, which is the primary key. You have the product name. So there are total 77 different products. Okay, and then you have the supplier ID, you have the category ID. So these two columns are the foreign key columns. You have the quantity per unit, unit price, units in stock, units in order, and if you want to reorder some product to fill in the stocks, so you have information for that as well, and if the product has been discontinued or not. I'll copy this and let's see what rows and columns we have in my categories table. Okay, let me execute this. Okay, so we have total 8 categories of products. You can see beverages, we have dairy products, meat or poultry, you have produce, seafood. These are the description. Okay, now to find the total number of products in each category, I'll write my query as select. I'll write category name, comma, count star. I'll give this an alias name as total products, give an underscore and write products from my first table, that is products, give an alias as P. I'm going to use an inner join with my categories table, and I'll give my alias as C on my common key column, that is P dot category ID is equal to C dot category ID. Then I'm going to group my results based on the category names. So I'll write category name and we'll use the order by clause. I'll write order by count star as descending. So let's see the total number of products that we have in each category. So this shouldn't be as descending, should be just count star descending. Okay, I'll select and run it. There you go. So here on the left hand side you have the different category names, and on the right you have the total number of products that belong to each of the categories. Alright, now moving on to the final question. So the last question is to use the Northwind database, and using this database we want to find the list of late orders for all the employees. So this is a real world problem that often occurs. So the shipment of your orders might get delayed due to logistic issues, or if the products are not available on time. There can be various other reasons as well. So here we want to find those orders for the employees where the required date is less than the shipment date. So we are going to use two different tables, that is orders and employees. Okay, now let me give my comment for the final query that we are going to write in this interview questions tutorial. So using the orders table, I want to find the list of orders for all the employees. So I'll just give list of late orders, not just orders, for employees. I write EMPS, which stands for employees. So here I'm going to use two tables, orders and employees. Orders table we have already seen. Let's see the rows and columns that are present in the employees table. I'll write select star from employees and let me run it. Okay, so there are total 9 employees we have. So we have the employee ID, this is the primary key column which goes from 1 to 9. We have the last name of the employee, the first name of the employee, we have the title, then we have the title of courtesy, whether doctor, Mr., Mrs. We have the birthday of the employee, the hire date or the date of join. You have the address, city, region, postal code and other information. Alright, so let's see how you can join the orders table and the employees table to get the list of late orders. And we must remember that late orders are those where the required date is less than equal to the shipped date. So I'll start with select e dot, I'll write employee ID, comma, I want the first name, comma, I'm going to count star as late orders from my table orders as O, then I'll use my inner join. I'll write employees as E. It doesn't matter actually if you use small e or capital E. Then I'm going to use my on condition on e dot on e dot employee ID equal to O dot employee ID. So this is my common key column that is present in both the tables. Then I'll use my where clause where. Now you should be careful and you should give the right clause. So my required date should be less than or equal to my shipped date. So this is my condition, and then I'm going to group by e dot employee ID, comma, e dot first name, and then I'll use my order by clause, order by my alias name that was late orders, and I'll arrange it in descending order. So let's run this and see our result. Okay, so you have the employee IDs on the left, then you have the first name of the employee IDs, and then you have the late orders for each of these employees. So if you see here, employee ID 4 has the highest number of late orders, followed by employee ID 3 and 8 as well as 9 who have 5 late orders. Then we have the employee ID 2 which has 4 late orders. Even employee ID 7 has 4 late orders. Employee ID 5, that is Steven, has only 1 late orders. So we are done with our demo section and we have covered all our 30 questions, out of which 25 questions were based and used on MySQL server. And to address the last 5 questions, we used our Northwind database that had a lot of tables. You can see it here, and using those tables we solved some interesting questions. I hope it was useful and informative. If you have any queries, please feel free to put them in the comment section of the video. Thanks again, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.